Everybody, welcome to another stream. How are we doing? Hey there, Mr. Test. Oh, awesome. How did you find out about about the about this the series and everything? Yeah, I chucked them straight up on YouTube. So they come out pretty much instantly, which is great. I've been hoping to do more YouTube content, but it's just so difficult to fit it in. Like, I get free Saturday morning sometimes, but it's hard. Hey there, Rohan. Yeah, I got a haircut. Look at that. Looking fresh, eh? Got a nice shaven beard as well. See how skinny my jaw really is. Hey there, Roger. How you doing? Hey. Yes, just post that we're live. Easy to miss that. Right now, okay. Right. Okay, last stream. We got hot plugging working, right? So this stream, so we started looking at like what it takes to get, or we started looking at xinput2 and like the keyboard, the mouse having two mice plugged in. And we saw it as working, so we just gotta now get the events plugged in basically. But I was having a bit of a think, and there's probably something we want to do. Thank you so much, Roger. Thank you. Appreciate it. Yeah, so I think we want to distinguish the difference between like mouse input and probably the virtual pointer that moves around the screen, that virtual cursor, because you can have multiple mice plugged into this game. So I think we want to have like a virtual mouse, maybe a virtual cursor, and maybe with keyboard, because I'm thinking like sometimes you might, because the thing is about the mouse and that you probably just want to deal with like relative positions from the OS, from the operating system. Maybe. Like, they each have their own cursor, but you kind of want to have like a, because if we have like an editor or something, you kind of want to use the operating system cursor, right? Because it's just nice, so that way, like, you get the whole mouse focus. It's different from keyboard focus, and that can integrate into the game that way. But if you were to have multiple mice plugged in and there's like an in-game cursor or something, yeah, that'd be completely made up, right? Yeah, so I think I want to expose both from the OS layer, I think. I think we'll start off with that today, and then we'll plug in all the events for it, and then make a start on the game controller. That'd be really cool. I found that there's a program that we can use, right? It's called evtest. I think I've got to get it. Yeah, so this sudo pacman evtest, or is it extra evtest you have to type? There you go. So apparently we can run this guy, and it will just print out all the events. So I've just got to find the doohickey. Where is it? So I can just plug it in. Okay. So just gonna plug the device in. And apparently you can use evtest. So we just need to check to see what should I run my little test program that we did before, right? And then we can tell. So I in the test folder I have this test program which basically just uses evdev and just dumps everything. So we just want to find where it says Sony. I want to find where it says event basically. Well, should we look for joystick? There you go. This one, event 19. So apparently we can just run this. This is interesting. So we should be able to say ev test. This is event device, the evdev stuff. And apparently you can just do this, right? So the problem with the analog sticks is they've got to be perfectly still. And if they're slightly offset, they will just print out garbage. But yeah, I'm pressing like R1, L1, and you have these buttons that show up. Triggers, and you're seeing there's like a value, like an analog value. So yeah, this is interesting. I'm pressing the face buttons now. Face buttons, right? And then I'm pressing the... So we can use this to know what enums to use. And the thing is we might need to plug in different controllers and see if we get different enums. So I think we might do. And I only have a PS4 controller though, because I was looking at my parents' place at the weekend or yesterday for for an old 360 controller. So hopefully those would, give something different maybe, but I don't know. Yeah. So this would be useful. There's also like the accelerometer as well. You could probably do. Accelerometer, that is event 20. So let's just try 20, that'll be a bit of fun. Oh, you gotta use root? Really? Oh, we better not have to use root on this. Yeah, so apparently we've got accelerometer and maybe the gyro in here. We'll have to see about that. It's hard to really tell. Yeah, it's really hard to tell. It seems like it's feeding... Yes, I've just laid it flat on the desk. I don't know. It's hard to tell. But anyway, we'll be looking at that later. So this is a bit of a tease. But for now, we're going to focus on the keyboard and mouse stuff. But yeah, I hope everyone's having a good weekend so far. So essentially, we want like a virtual mouse and maybe a virtual keyboard, and this is like a combination of everything. So it's not really an input device where you can receive raw inputs from those. It's more just like the whatever the operating system one is. So I think we might want to say the problem with that though. Yeah, so maybe we'll just put it in the keyboard and in the mouse section. I'm not sure. So where it says mouse position and all of that, we might have like virtual cursor, maybe position. So you just take in a void. So we might put it in a separate, actually let's move it underneath it. Underneath all this input stuff. So I think we'll do something like virtual cursor. So you'll be able to get the relative position, probably the scroll as well, right? So let's go up to this mouse stuff. Just get all the buttons. Virtual cursor. Okay. So we don't want to take any input device in because this is just a combination of all of them in a way. So let's drop those in there. So how about the keyboard, right? So you might just want to, rather than having to look at an individual keyboard, you might want to look at just the all of the keyboards as a whole. So maybe we'll just call it a virtual keyboard, right? So we'll just say basically like the mouse cursor from the mouse functions to access the data about the operating system's, built-in mouse cursor. So this is, so it's not, it's just too much stuff at the beginning here. We'll just say the OS's built-in mouse cursor, so like multiple mice. So you want to say like which is shared between multiple mice. Now, something that we also want to be able to do is when they click, or when they go into a certain place in the game, we might be like, I don't want to see this virtual cursor anymore, right? Hide that for me, right? So we obviously want like a hide and a show. Probably not a ball, so we'll need some of those as well. So we go to hide and show that, which would be proper good. And now we also want is a virtual keyboard. So the OS is built in which is shared between multiple keyboards, something like that. So I'm not sure what sort of API we want, because the problem is there's like translation between different key codes and things like this. And I think each keyboard has its own, maybe. But I don't know if it does, because down here, so this might be, I think that's just so I think this moves down, and it can just be, well, this can just be, I don't think you need I think this translation can be global. We'll have to think about that, but yeah, we'll leave that one out regardless. And we basically just want this, I think. So we just want like so I keep using the word vert already, so I'm just gonna use the word vert. Okay, and then this keyboard here is gonna get virtual keyboard. So it converts the key code. Sorry, it uses either the key code or the virtual key code and checks to see if keys are pressed. Now we don't need obviously this input device anymore, so we can just drop all of that. And there we go. So that'll be good things to implement. Are we missing anything? Right, so it might be good. Let's just have a quick dabble into the Linux side of things and just see about the keyboard code. Because I don't know if the keyboard, I don't think each keyboard gets its own map. But maybe it can. But I don't know. Did you already choose the graphics backend you're going to use? No, we're not doing software rendering. Well, we kind of are doing software rendering, but on the GPU. So we're just going to leverage compute shaders. So I've got a video up on YouTube going over that. So there's this devlog 0, which goes over a sort of a plan of what I want this project to be, and what sort of we do on the graphics front. And then we spent the first, and then on the VOD channel, if you want to catch up on the specifics and see, like, how what we did to get there, and I've done Vulkan so many times, and it is only compute, and I've obviously got my own shader compiler as well. That we did just sort of blast through that in like 5 or so episodes. Like it's taken longer to do this input stuff, basically. So we did Hello Pixel. Okay, sorry, I lied. 10 episodes. Yeah, day one, which was setting up the whole project. So we basically went, and then we like ported to Windows day three what we had, and then we went over to do get resources up and running, buffers and textures, uploading to them, reading back, getting printf working in shaders day 7. It's all here on this VOD channel. I'll link to that as well. But yeah, if you ever want to take a look at that. So now we're on obviously some core engine bits. But yeah. Hey, what's up? Hey. Can I ask a noob question about Vulkan? Sure. I can't seem to get my code to work with mailbox present mode. I only need 3. Yeah, but it's giving you 5. Yeah. This is you're probably on an Intel card. I had the same thing on my laptop. How do I require 3? How many fence, swap chain, image view become a buffer? Right. Milton time. So basically it says there's 5, right? But that number doesn't matter to you. All you need to know is if it's 3 or more. 5 is like, okay. So basically, at the start of your frame, you want to acquire your swap chain, your next image, and it will possibly wait here if maybe you've given like 3 frames worth to the GPU and it can't assign you a next swap chain image index. Now what you need to do is if you've got image views and frame buffers, right? So when you create this, when you create your swap chain, what you want to do is you want to have 3 lovely image views, right? Wait, how many image views? 5 image views, because they gave you the number 5, right? Because they can give you back anywhere from 0 to 4 as an index, right? So you need 5 image views. Now, so when they give you back an index, they'll be like, oh yeah, use that index. And you go and use that one. Oh, I need this one. Where's that one? Right. So now the next thing you need to do is with frame buffers. So there are core extensions now. By core, I mean they're basically it's supported everywhere. And they've moved into like core 1.2 or 1.3, where you basically don't need frame buffers anymore. You can do imageless frame buffers. I would highly recommend that, because then it means you can set up a frame buffer. You don't have to manage frame buffer objects. You can just manage render passes. And if you don't want to manage render passes, you can also use the dynamic rendering extension, which is in core 1.3 as well. So it's Vulkan imageless frame buffer. I highly recommend using this extension because it allows you to, isn't it just create a single? Right. Normally you'd need to pass image views, right? But instead you can pass it when you begin the render pass instead. So you don't have, so basically the frame buff stuff's done, maybe done behind the scenes at worst, or not done at all. So you don't have to manage these VK frame buffers anymore. You just create one frame buffer and one when you create your render pass, and then that frame buffer just belongs to that render pass, and you can just, when you do your VK begin render pass, you can use that, where is it, the attachment, where's the begin? Anyway, I'll send you a link to this. This is the jam. Because then what you can do when you begin your render pass is you can have this in the p next, in that void pointer, it can point to the extension, which is the attachments, and you can just go here. Here's my swap chain, and here's my depth attachment, right? And then like it's just far easier. But yeah, if you don't want to deal with render passes just yet, there's another extension for you. Again, Vulkan is a bit complicated, and I wouldn't if you're just picking it up, these two extensions can really help you out. And this, like, though, I think imageless frame buffer came in 1.2 core, I think, don't quote me, but this one came in 1.3. And this is, so you can just literally enable it as a feature. You don't need to use it as an extension. It's just built in, and you need to just enable the feature in the 1.3 features. But this one allows you to not use render passes, and you basically use this dynamic rendering thing. And I highly recommend doing this first if you haven't done anything. Yes. That's my advice. I'm not sure if you're early. No, on Sundays I usually start at 4, but I actually started a bit later today, which is a shame. But hey, Meeborn, how you doing? Good to see you. But yeah, what's up? I hope that answered your question. Sweet. Yeah, dynamic rendering. That's it. Yeah, it's a good one. Yeah, because Vulkan is Vulkan, you know. Is it gonna? It's not like OpenGL, right? So the reason why people in OpenGL wanted to support the lowest version possible is because GPU driver vendors didn't used to keep up and support like old cards and stuff like this. But with Vulkan, like as soon as Vulkan came onto the scene, GPU vendors like got so many devices ported over, and okay. Went back. Later on, that OpenGL problem went away because most vendors actually started to support OpenGL 4.3 and all of this, where you have compute shaders and everything on like but in Vulkan, as soon as it came on the scene, they ported so many devices over. There was and even like NVIDIA 980s, I think. Like no, we're not talking about 1080s, we're talking about 980s. Those have Vulkan 1.3 support, and they're like, you know, they're getting quite old now. So like it's you know, GPU vendors are a lot better at supporting these newer specs than they used to be. It even supports all the bindless stuff and everything, so it's great. I think on Android though they're on 1.2. Like Android has to all go up together because it's part of the OS or something. Something to do with Android. I wrote a string pooling thingy in C. Awesome. It can check if I added a string already exists, returns a pointer to the index. Yeah. Actually, in64 or existing copy. Nice. Simple Lexa recognizes single token symbols, identifies. Sweet. Yeah. I already do like string deduplication, especially when it comes to compilers. It's a good idea. Basically continuing what they were doing. I'm not sure if they're basically continuing that. Like Vulkan's a lot, yeah, has a lot of problems, but they do a lot better at supporting the newer stuff. On Intel cards, for instance, you got stuck on like OpenGL 3.1 or whatever it was for ages, and eventually I think they got around to supporting. What's the difference between a Lexa and a parser? Lexa is tokens. So you just know this is an identifier, that's an identifier, that's a parentheses, that's another identifier, parentheses, semicolon. And you use this in your parser. So you parse the tokens and the contents of the token to then build a syntax tree, which is more of like I have like a function and it's got a bunch of instructions, and it's like a tree of everything that's going on, basically. Yeah. It's a little bit more concrete. Okay, so we're going to go ahead and do some... We're going to go into the OS side of things, which sits on top of the operating system specific bits. Gamepad action value. Let's find that one. So we're going to drop these in here. So we're going to get this virtual cursor and virtual keyboard. Thank you, thank you. So I think we want to repeat the OS keyboard and OS mouse. OS mouse. We want to repeat that and put it. So do we want to retain a position? Maybe. Yeah, I think we will want to retain it. I did delete a function, so let me go and get that one back. I'll put that one back. I just deleted this one. Right. So the plan is to take this keyboard and mouse. I already got it there. And we want to put it back in the OS thing, because it used to be in here, right? Because we used to have one keyboard and one mouse. But then what we did is we made an input device, which is just something. It could be keyboard, mouse, could be both. Could be a gamepad, could be accelerometer, gyroscope, all that goodness. So we're bringing these back, and they're going to be used still. So let's just go ahead and plug these all in. So just literally going to do a return G OS, but we should call it the mouse for that keyboard, because otherwise it could get a bit confusing. That mouse. Position. Hey there, Majestic Mac, how you doing? How's it going? It's been a while. How you been? Very good. Let's just plug all these in. Relative position. Oh wait, too many. What is? Oh, oops. All right, less typing. Wheel. Sweet. If it's pressed, yeah, we just return G OS vert mouse is pressed bit set. Button has been pressed bit set. Has been released. There we go. So now what these new ones called hide and show. So what I think we want to do is keep some. We're going to have to call some back into the back end. We can't just wire these directly in, I don't think. Maybe. Maybe we can wire these in directly to the back end. So yeah, we've got to. What did I just do there? Okay. Yeah, I think we're going to wire these directly into the back end, because it probably doesn't matter if we call show twice in a row or hide twice in a row. I don't think it matters so much. So we're going to OS Linux. Now, do we have to initialize these at all? Let's just have a... No, they're all just... Right, they might have to get reset. We'll think about that. Okay, we're going to find any gamepad or keyboardy bits. There's input device, isn't there? Space device. Huh. Okay, we'll drop it in here. So virtual cursor, we'll have the ability to hide and show the virtual cursor. We'll implement that in just a bit. I want to come back and remember, let's just put some garbage in here, so just in case, right? I want to remember the fact that we've got this, we've got to reset these bit sets every frame. These two, these has been pressed and has been released. So that's in frame initialize. So we want to take, and the relative stuff. Yeah, so I'm going to take these. Oh, right. And what we're going to do is just gos.vat mouse. There we go. That's good. Good not to forget that. So we should also implement the keyboard stuff here as well. Wait, did I go and get those? Right, these can go, because they call into the backend now, right? Straight into the backends. Oh, working the usual. Yeah, man, I know what you mean. It's the post-COVID life, I'm being immature, but I can't help but giggle. There's a brand of electronic gadgets named Gaia with an E. It's not. Oh, it's Gaia. Oh. Wait. Oh, Gaia instead of Gaia. Right. Yeah, they probably dodged a. Yeah, they probably said that's dodge a bullet. Maybe it's always been the way. Yeah, it sounds gay, which is kind of taboo. Yeah. It must be so confusing. Like if you're trying to communicate that to someone. How's the implementation going? It's getting there. Not delay. We got yeah, we're getting close now. So we've got we got hot plugging working last stream. So we're literally just about to plug in the rest of the events and everything with xinput2, and then start taking a look at the gamepad stuff. We are plugging in the gamepad and multiple keyboard, multiple mice. I've just got this new EV test thing, which allows us to basically plug in, look at one of these event file descriptors, and it just logs it all out into the terminal, which is super handy. So we'll be able to see like exactly what buttons we want to program up this controller. But yeah, so I got PS4 controller to test as well. So maybe hopefully they're the same. And I can't find my 360 controller anywhere. I went around my parents yesterday to try and find it. So yeah, I want to go and look again at some point because it'd be good to test if they're any different. Do you have Gaia phones or Gaia phones? Yeah, excellent. Yeah, it's definitely confusing. gos.vertkeyboard. Right, that'll do it. Is pressed, has been pressed, and has been released. I'm doing Windows gamepad implementation for Xbox controllers and the PS5 one. We'll try to do PS4 one too. Awesome. Nobody sells Linux laptops anymore, not even like 11. Yeah, I think they used to be called netbooks. Right? I liberated other people's work. I had liberated other people's work from the internet. Sweet. It's a way to do it. Yeah, it's because I maybe saying on Windows, different controllers give you different like enumeration values back. So my thinking is Linux is probably the same because I gave a lot of part of my reason of wanting to doing this myself is I gave a lot of blind praise to SDL about how good it is because it does this controller support thing. And I just heard that from someone else and just parroted that. So I wanted to try and do it myself and see like how much of a ball ache it really is. Figuring it all out because there's not too many resources on the internet has been the biggest struggle. So the next thing to figure out is like on Linux, do most controllers have like a standard or do you need a button mapping? We probably might need to do some in the future, right? Do some button mapping. For now, it's not a problem, but yeah, and it shouldn't be too difficult. Anyway, I'm using direct read file, write files to communicate with them and decode the data. Sweet. Look at that. Yeah, I think it's basically the same on Linux as well. With a read system. Cool. Yeah, be cool. Wait a minute, I just nearly auto-piloted that. Give me a second. Vert key code. Right, it's a difference. Key code is always QWERTY. Virtual key code is whatever your layout is, and typically you always want to know based on a QWERTY keyboard layout because it's physical positioning, right? Is pressed. Oh, we're just returning the bit set because this bit set is just it's easy. It's not like an array of words that you have to index precisely. It's just it's one word. It's one 16-bit integer. And also by word I meant just one thing. It could have been 32-bit, 64 bits, but yeah. Cool. So that's all the high level bits done now. Actually, no, is it? We need to have events for these as well. So we're going to go and plug those in, get those events in here. So last stream we added input device connected and disconnected, and we got that all working. Really cool. So you can unplug, plug stuff back in, do all the problems with that. So that I can use all the important features like adaptive triggers, vibrations, touch. That's another thing. I haven't looked into that stuff yet. When adaptive triggers, vibrations. Yeah, I haven't looked into like the vibration stuff. Oh, the adaptive triggers. Yes, these things. Yeah, because you can sort of like make it harder. Give you. Yeah, it's pretty cool, but easier to break as well. But yeah, I want to. Yeah, in future I'll probably look into that. Just now I need something generic to go with. Yeah, be a good idea. Have I looked into Raylib? Yeah, I've looked into it. It's decent for those folks who want to come down, learn some C, do some visual stuff. You know, it's good at just getting up and running and having to play doing gameplay code directly using C. But yeah, typically, but yeah, like if you're like an engine developer, it's not, or if you want to sort of, I think, yeah, if you want to learn how to make games using C, Raylib's like a good first step. If you want to continue making games, you could use Raylib, or there is like SDL, which is a bit more of an advanced version. But you know, or like if you're like me, where you want to learn how to make engines and everything, I did use SDL for a long time. Then I did my own stuff. But then I went back to SDL because it just did the gamepad stuff. But now I'm taking the leap and doing more of the even the gamepad stuff by myself and everything underneath. So, but yeah. Or you could go the route of C++ 23 template metaprogramming and make a compile time game. Okay. If that's I don't know. My compile time games are like, you know, how quickly can we make this thing go, you know? I like my compile times being like basically 0, please. But yeah. Hey Ross Compiler, how you doing? I hope you're you know, everything's happening in a safe manner. Yeah, so we want to add like probably a separate one to say like virtual. So I put these like down here. Virtual keyboard, virtual mouse. You know, we need all of these. Text input. Text input kind of comes from the virtual. What is it? No. No. Yes. So we're using the term like virtual as just a combination of every single keyboard and mouse into one single thing, basically. All right. We'll get all those in there as well. So I think yeah, and we'll be fine. So all of these guys basically that we just copied and made a virtual one, whenever we fire those events, we also fire a virtual event as well, basically. You know, you could make it a more complicated thing where multiple keyboards can go to one virtual thing and there's like multiple virtual things, but it's just, we'll never need that. The whole point is just, the problem that it's solving is so, one, the mouse cursor. The mouse cursor, we can use the operating system mouse cursor, we can hide it and show it, and we can have that interacting with our built-in like editors in the game. But then if we go into the actual game itself, we might want to split. We might want 2 separate mouse cursors to show up, right? And those are sort of like, those will use the raw input, the raw events and stuff like that. And the system mouse would hide at that point. But yeah. Okay, so now we can actually dig into the low levels, so the operating system specific bits. So we're going to do some cursor hide and show. So I completely forgot how to do this, so we're just going to Google for it. I want to log out of Google. There we go. As an engine developer, it's important to learn how to write a hardware abstraction layer, as you most likely be tasked with writing one as a new platform emerges. Multiple keyboard support is a nightmare, as some mice are seen as keyboards. Dun dun dun. Yeah. The way we've solved that problem, and I didn't solve that problem because I knew about it. I solved it because of the way it's been designed. But yeah, I'm glad to hear, I guess, that I've maybe solved that problem. Basically, we have the concept of an input device, and an input device is everything, right? And it just has a bunch of features on it. The features are keyboard, mouse, mouse, keyboard, gamepad, touchpad, accelerometer, and gyroscope. And it does take up more memory, right? Having all these bits in, but whenever you connect a device, it tells you what it is, and yeah, you get all of the features in one abstraction, basically. So yeah, I hope we solved that problem that way. Because the problem with the gamepad is the gamepad could have an accelerometer or not an accelerometer, and that sort of stuff. So it's just got feature flags. So we're just going to Google for X11 hide cursor. Now, from what I remember, is there's two different things. There's hiding a cursor and trapping it. So we just want to do both things, right? Because the idea is you can hide the cursor, but your cursor's still moving around the screen, and it will allow you to escape the window. Right. So imagine this is my game window. But the cursor will be invisible and allow you to escape the game window. And then if you click, it would just be outside, but your mouse will still be hidden. We don't want that. We want to trap it and hide it. So we're just gonna, use the internet. I think it's called X trap cursor, X hide cursor. I'm not sure. evdev server has xfixes extension. Call this guy on the root window to hide all cursors until the program exits. Yeah, we don't want that. Yeah, maybe there's a polar opposite thing to do. Why are they all telling me to boot X11 and hide cursor? Or no cursor? Right, maybe we just say right, this looks very codey rather than very system admin-y. Right, so they are using this fixes thing. It seems like it toggles. Okay, so xfixes. Oh no, there's a hide and there's a show. Right, so I don't know how good this is though. We'll look at it. Maybe it does. Or maybe you have to manually trap it yourself, I guess. I don't know. Alright, let's read the docs on it if there's any docs. Right. So this is part of the X protocol. So you're seeing just hide and show cursor. Sends a request to indicate that the client, to indicate that it wants the cursor image to be hidden, i.e. not to be displayed, when the sprite is inside a specific window or one of its sub-windows. If the sprite is inside the window, for which one is more when is active, for which one is more active. Yeah, so it's basically saying if it's inside an active window and it's got this on, it'll hide it. But if it runs out, okay. Yeah, then you want to trap the cursor after that because, you know, otherwise I'll just be able to like, yeah, escape, start clicking everywhere. But this sounds like quite a decent one because it's like only while it's inside the window, and maybe we should have a separate. Excuse me. API to trap and untrap possibly. But yeah, I think we can just use this guy. So let's look at. So there's this. Try that code out. What about trapping then? Xlib trap cursor or capture as it's called, I guess. Right, what's this grab pointer do? Actively grabs control of the pointer. Further events reportedly reported only to the grabbed content. Whoever has any active. I'm not sure. Is this too much text to read there? So that's to lock the cursor. We don't want to do that. We want to keep it within a region. Obviously, you could conditionally do that. When your program receives mouse events, it receives a copy of the events. Copies, some type of programs. You can select input. You cannot override this without take ownership of the mouse, which will prevent other programs from receiving any mouse events. In short, you can't do this. Right, what's he trying to do? Invert the mouse movement. Okay, no. Doing okay, but not good either. Currently in the progress of porting pure C game engines to C++11. My editor UI code became too complicated to comprehend in C style, so I'm writing OOP style to be much easier to reason about it. The rest of the engine will remain data oriented, though OOP is nice for editor widgets, etc. I don't know, like, I don't know. There are different approaches you can take still. Like you can do like the whole, basically your widget has every feature and there's no sub widgets. Basically approach. But yeah, fair play. Yeah, the problem with UI code is it kind of gets messy quite a lot of times anyway. Yeah. It's quite difficult to get a UI. First of all, design a good UI API. Like it takes a lot of attempts to sort of understand that. Yeah, and also it had to keep the code clean. Is there anything on Linux like raw input on Windows? Yeah, you can read. So I don't know what raw input is, Mr. Shelby. But yeah, I think there's like you have kind of system access to. Oh, for gamepads, yes, but not for keyboards and mice. I don't think. Keyboards and mice, you can still get the raw input, but it has to go through X11 still. And there's an extension to get the raw input that we use because it's built in on all of them anyway. So there's a warp pointer, and I guess you can warp it if it goes outside your bounds, right? But isn't that just annoying? So we could take a look through the SDL code and take a look how they do it, because as you can tell, Googling for it has been a bit difficult to find out exactly. But let's see if we can find anything else. So there's a warp cursor. So obviously manually we can be like, oh, if it goes outside the bounds of the window, like just teleport it to the, you basically just min and max it, right? Or you clamp it. That's another way of saying it. All right, let's have a gander through the SDL code, right? So SDL source, what is it in the video section, X11. Now, what's in here? So they do X fixes here. They do use it. And they use it to do the, there's a pointer barrier. There's a left barrier, right barrier. So they're barriers in this X fixes thing. That's one way of doing it. Fair play. Yeah, I'm not sure how much we need this right now, but I guess we can. So there's this thing called X fixes barrier. Version 5 introduces pointer barriers, which allows easy to reach. No, maybe that's not right then. Or maybe it could be used for that. Yeah, so what function does SDL have again? It's a like it's called capture mouse, isn't it, or something like that? To track input outside. To obtain mouse events globally. So is it set window grab? What is this? SDL warp cursor, but there's like a warp cursor in X11. I suppose they had a method to trap it inside. Right, is relative mouse mode true? Oh, so maybe it was that relative mouse mode thing. Alright, for example, we mount to track while in relative mouse mode, the cursor is hidden and the mouse position is constrained to the window. Yeah. Yeah, so this is what we want to dig through and just see what they do to set that up basically. So we can grep, right? Good old grep. See what that's in. So that's in obviously mouse. Wait. Yeah, Manjaro, man. On the Manjaro hype. And MGUI is also a thing. See if it's too hard. If it's too hard to CPU, I want to run a mobile in the future. Fair play. Yeah, MGUI is if you're a programmer, MGUI is like pretty decent, right? The problem with retain mode. Well, this is something I want to re-explore again when we do the UI stuff for this game. We will be doing that next after this input thing. Or input some maps any virtual key codes. It just gives you the stuff the hardware sends. Yeah, so you can get that. Yeah, you get that anyway. From X11 doesn't do any mapping. You have to do that manually in X11 anyway. Yeah. But yeah, you get raw input. You raw mouse and everything like that. Where is the bugger? Here. SDR mouse. Right, look at that. Source events. That's probably going to call into some backend thing. Relative mouse. Right, so set some focus and all that. Right, not really fussed about. So perform warp mouse. Wait a minute. Right, so they can like it seems a lot more complicated than I would hope. But yeah, so update mouse capture. Huh. So I guess there's this relative mode that you should really. Right. Move cursor. What is this? What is this thing here? Send mouse motion. Right, so that's when they queue up all their things anyway. But yeah, so I guess they call into the back end somewhere. So it might be good to see like what mouse warp in window. This one looks like a possible candidate for something. Perform warp mouse. Perform. Oh, I said wrap. Okay, so this one says it's in video. I guess that goes into the actual backends though. So video. Where's the bugger? Which one was looking for again? That one. Oh, it wasn't in there? Oops. Oh, it's defined in the mouse thing itself. Okay. So I guess it just warps it. Okay, it warps it into the window when you set it relative. Okay, so we'll just warp it. If it's outside, it warps it inside. Update mouse capture. Then focused in the window. There might be this one. Okay. Then it calls this capture mouse thing. So they might be using. So yeah, I don't know. They had that capture mouse API, didn't they? It was here. Capture the mouse and track the input outside the window. May also deny any other windows. See the mouse. Right, so maybe this is the. Oh. Right, so just grep for that and see what that is. Update capture mouse. Oh, mouse capture. Oh, come on. Was that in the same file? Did we look? Ah, okay. Must have been. Right, then there's another. Oh, right, sorry. But it calls that mouse capture function pointer, doesn't it? So we just got to find where that gets set. Oh. Capture mouse. So where do these things get set? X11 capture mouse. X11, X11 mouse, okay. Was we in there before? Video, X11, X11 mouse. Okay. This capture mouse thing. Right, so after obviously they teleport it into the region, the window, then they use grab pointer. So we did see that grab pointer function being used. So I guess we can reread it again. Sorry, we saw it and was googling for the answer, weren't we? Update grab window, and if not on grab pointer. Huh. Okay, so they use X grab pointer. Further pointer events reported to only the grabbed client. Yes, I think this doesn't hide it though. It just sort of traps it within the window. Yeah, I don't think this hides it. Okay. Got a lot of Microsoft there. They've got all the underscore AVX star underscores macros, but no SSE macros. Fantastic. Yeah, they also defined their AVX stuff as like a union. So you can't like type def it. You can't forward declare it. If you forward declare it, you gotta like not use their headers. It's fantastic. Because if you include the headers on Windows, they include like malloc.h, which then in turn includes a whole lot of other stuff. It's a great design. Yeah, the SC and types unions, so yeah. Okay, so I think we found what we need. So basically, you need to like warp it inside the window, just somewhere inside the window. Yeah, so I think it doesn't matter if you check if it's outside or inside. You just warp it to a corner or the middle of the screen. Just warp it there anyway, and then use this grab pointer thing. So, and then obviously make it hidden using the xfixes thing. Now, I think SD also has the ability to like hide the cursor, and obviously that probably uses xfixes maybe. So there was that show cursor one here. Oh, they just used define cursor. We did see that pop up in a Google result, didn't we? But we didn't. We did briefly look at it, but right. So that doesn't require like an extension anywhere, doesn't it? If cursor is set and the point. Right. So the thing is about xfixes hide cursor. If I feel like that one is gonna be like only if you hover over my window you'll be invisible, but if you go over someone else's window you won't be invisible. Whereas this one probably just hides it like across all the things, and but it's more portable, so it's probably just best to use this one. But yeah, I think we've got an idea now. So we can probably implement this quite easily. Now in this game, we're not going to want the ability just to trap it inside the window. We're not going to want the ability to just hide it, right? We just want to do both at the same time. But I think I kind of did it wrong. So let's just quickly correct it. I think we want to let's label these like backend whatevers. You know what? Actually, we'll take these with us. Oh, plop them down here. So these will just say OS backend virtual cursor. Show. I'm gonna hide, but they will then call. They'll say like GOS dot. Now we should probably have like in the global, like is the virtual cursor hidden or something like this. I don't know where it should go. We could chuck a couple of balls in places, but just use some flags, you know. OS flags. Get nice enum in there. OS flags. Virtual. Vert mouse. Hidden. Wait. Oh yeah. Don't know how much we'll use this, but there we go, it's there. __ M128 on Linux is a simple type. On Windows, you have to specify what kind of 128-bit register you want. I don't know, I swear on Linux, maybe I haven't done enough of this stuff. On Linux, you have a float one, you have a int one, right? Very irritating when you have a hadd function, where Linux you can just do. Oh, you have to use union it. Oh. 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 Yeah, that's not good. I don't know why this is just different, because it's the same hardware. You know. Yes, we're just all the bits. Wait a minute. Wait a minute. Cool, so I guess afterwards we'll put it on. Right, so say GOS flags, so all these buggers on here. And then we'll and not it, right, to remove it. Oh, always get that wrong. Cool, nice. So we're gonna go into these are gonna be called backend whatever's, right? Backend that, backend this. And I wanna go ahead and grab these and put them in the internal header. Which just, you copy paste them. Really, they should be sectioned a bit. After the input device, because they're kind of separate. And we'll just do the forward definitions like that. There you go. Oh, sorry, forward declarations, that's what I mean. Nice. So now what we're going to go do is actually do some specific code. So we do want to use warp pointer, just warp it in the center of the window. And also, do we even have the window position? It might be handy to have this just laying about. I don't think we have it. We don't have the window position, folks. So we'll just put that in there. Yeah, so we'll just set that. We've got to probably do an event now. Like a window resize, also do like a window moved. Which then means there's like a resize down here, which then means there needs to be like a move. Oh, it's like a mouse move. It's basically the same thing. Oh yeah. Just about the well then. Window moved. Fantastic. And we kind of just want to go into the internals and find the window resized thing and just make one for the moved. And where's the mouse moved? See, it takes in a position. You'll have to sort that mouse one in a bit. But we'll go ahead and just drop that in there, and we'll finish that in just a second. Just put some crap in there so we can not compile it and pick it up when it becomes a problem. So, okay. So now we've got this window position thing, and we only have one window, right? So this becomes a lot easier, I guess. So we're in the Linux backend doing Linux specific things. We just want to find a nice center position. So center position. So really, the position should probably be like top left. Wait, we're doing bottom left, aren't we? Yeah. Should we document that? Yep. So everything's from the bottom left. I know people like top left, but we're doing 3D as well. And bottom left just makes a whole ton of sense. Just make everything that. Center position, G, OS, window position, plus the half. So I think I can say like multiply G, GOS window size 0.5 F. So I need to say like mul S for the scalar as an arg, and this needs to be add G. So that's just some little generic macros I have to do like different vector types and things like this. Why you know work? Oh, they're not defined. include hmaths generics. Oh. F16 times 2, what are you saying? Why is there no F16 times 2? Oh, did I not? Okay, F16 is the first one, so I need to include vector, that's why. Oh, right, div2. Div sg2. Nice. Now roll. Oh, what is this ran? Just gonna take a gander. Yeah, it's MMID, but I think Windows, all of them are just inside of a union, right? To create backward compatible APIs. Just a library for compatibility. Oh. So, so it tells you if you break an API or an ABI. That's quite useful. So you can put this in your like build machines or your Git, whatever they're called, the hooks, right? It's interesting. Not sure why something like this didn't exist earlier. Maybe it has existed for a while. Yeah, sweet. Why have I become this guy? Look at me. All these tabs. I'm not this type of person usually. Sweet. So we want to find that center position. We want to do a warp. So x11 warp. Moving the pointer. Warp pointer. Whoa. Oh, so you can do it like it's quite simple actually. Wait. Nice. Just so next warp pointer. Warp putter. Warp my putter, please. So we need our display connection. So we need the OS Linuxes. So we get our Linux backend from the global. Right, our display connection to the X server. Then we need a source width and a destination width. Source can be the source. Oh, sorry, window. Source window. Source W is window because it says here window. Or none. So we can just put none. None. Oh, so you can take it from one window to. Ooh. So could you just put none twice? I saw the guy put like the root window. If this is none, moves to offsets relative from the current position of the pointer. Yeah, so destination window, and then if it moves it to to the origin of this. However, okay, bearing in mind, yeah, it should be fine. So we want to put in our destination window. So we have that already. So it's just OS backend. Wait a minute. We need to get the window. Do we do a thing called a window backend? Oh, we do a window backend. Oh yeah. So we want to be relative from that window. So let's go and get that one. Boom. And then we do source X, source Y. So I guess a relative from the origin. If height is 0, then it's replaced. Wait a minute. However, if source window is a window, the move only takes place if the window contains a pointer. Contains the pointer if the specified. Right. X and Y coordinates are relative from the window. Yeah, so these can just be 0 then because we disabled that functionality. So 0, 0, 0, 0. And the last two are the destination within the destination window. So that would just be center position.x and center position.y. We don't have to swap it from bottom to top, flip the y-axis because x11 is top left, whereas we're bottom left. But we don't care because we're simply doing half the window size. So it's kind of fine. So we warp it to inside our window. That's step 1. Well, this is show, isn't it? Right, wrong one. So we mean hide. So warp inside our window. Then we want to. So define cursor will hide it. Right. So we just want to say, warp the cursor to inside to the center of our window. And then the other one is, so there's grab pointer. So this is a lot of stuff to read and work out. But yeah, let's just look at SDL's one because it's the same sort of thing we want to do. Wait, where is it? It's grab window, isn't it? Grab pointer. Wait a minute, mask. Let's read what that mask does, because we're not using these. We use an xinput. Is there an xinput API for this then? Extensions xinput2 grab modifiers grab device. Ooh. Yeah, but we don't. No, I think this is fine. Yeah, I think we'll use the standard API actually. Let's grab pointer one. I think maybe we'll keep these events going. Right, so basically what we want to do. So the mask for the which pointer events are reported to the client? Mask is odd. Right, event mask. And is only reported by the event mask. Right, so it's just saying report these events. Focus changed, okay. Point of motion. I don't know if we need. Okay. Window confined. If confined. Yeah. So we want to do OS window backend x11. We also want to do it down there for the confined one. And then our display connection here. Now it returns something. So maybe we need to return a boolean if it failed. But maybe it shouldn't fail. X grab pointer. Well, Xev is pretty well maintained the culture of open source. It's very maintained the culture of open source principle. Look at that. Oh, they have it. They track actual open source projects. Okay. And do it automatically. Ah. Right. That's cool. Right, so you're saying like across the board, they seem to like keep backwards compatibility. Yeah, they kind of have to. Like they just add more API, right? They add more extensions. But yeah, they don't change anything. I don't know when was the last time they actually changed anything. You know, do they have like OpenGL? But that's different for each vendor, isn't it? Yeah. Hmm. Nice. Or zero symbols, 100% backwards compatibility. Yeah. They keep all the bugs in, all the security problems forever. Right. So that return. You know, should we return a boolean? Because yeah, we will have to call x sync as well. Because, or not x. You probably want to call x flush. So we don't care about waiting. Remember to call that at the bottom. So you know, so if we take a look at that, should we take a look at the? So they could refuse to. You know, but I don't know what I want to do if my cursor's not hidden, right? I can tell it is hidden. But how do I want to handle that? Because X warp maybe would have failed too, right? You can still keep the API as it is and make them safer after all. Link time magic. Yeah. No, I think like with X11 there's like an inherent sort of like, you know, they allow you to see like events from other programs and stuff like that. And that's kind of by design. That's a design issue, isn't it? But yeah, they can fix like, you know, if you overflow buffers and stuff like that, right? Yeah, so I think X warp pointer. I think this returns is a void. It's int. Yeah, it might return like an error. And do they handle that in? They don't typically handle that one though, but they don't seem to roll any changes back though if it's not been trapped. But yeah, it should always return true, hopefully, unless you're on some window manager that said no, I'm not supporting that. Right, so we've warped the mouse to the middle, we've done the grab. Now we want to do the undef thing, right? Where is it? so not x fixes, is like x undef, wait, defined cursor, and there's undefined cursor. So this would be like, you know, trap the pointer within the bounds of the window. And then we've got this guy. So we use our display connection and then on the window. And this one will like, you probably want to hide, yeah, we can just hide it to this window, but you might want to do the root window, I'm not sure. So just be like, hide the pointer. There you go. And then we'll flush it. So we want to take this and do the reverse, right? We don't care about warping, right? You know, we'll warp it to the middle. We'll do that. Then we need to ungrab. How does one ungrab? Let's just quickly see. Okay, X ungrab. There's a function for that. Okay. Ungrab, and it just needs that and the time. Current time, apparently. Then you want to redefine the cursor again. It takes more things. It takes a cursor. Alright, what is the cursor argument? Right, so they've obviously called a get cursor in the past or something like that. Create cursor. I don't think I've ever called, I've not called this. So let's see if we can do like cursor empty, and let's just see if that does anything, right? That might, you know, might be a bit of a problem. Oh no. No, that's not a good idea. Oh my days. Let's see if there's another way to do it. Define cursor example. Let's just take a look at this. Oh, what's this one? Create system cursor. But I don't know why we've got to create this, right? Surely it should already be there. And is this like some... xlib get cursor. Oh, coordinates. Query pointer. Demonstrates create mouse cursor attaching them to a window. Why is these things more complicated than they need to be? Create a font cursor, define cursor. It's a box cursor. So maybe like, create font cursor. Do they use that in here? Shape, ID. When they initialize the mouse, there's a create a system cursor or something. And they store that in some globe. Oh no. Yeah, they store that in there. Eh. Alright, so we can try this one out. Cursor. But we want to use like a left pointer one. Left PTR. We'll try that. I don't know how good it is, you know, what the problems are with this approach. But we'll find out. Cursor font. Right, we need that one. That header. Oh shoot, where did my thing go? Close my file. Cool. Right, so that should be the code to show and hide cursors. Wait, where's the warp? I thought we still wanted to warp it to the middle because you could have moved it, right? Warp it back to the middle, ungrab. Excellent. Sweet. So yeah, we can't test this out just yet, but we will, as soon as we get it up and running, we'll give it a go. But yeah, that was more complicated than it needed to be, in true X11 fashion. So the next thing we want to do is plug in. So we've added some new events where I've added this virtual cursor, virtual keyboard. We also want to plug in our raw keyboard and raw mouse stuff. Yes. So let's hop into the internals. No. Sorry, what I mean is the these internals actually. So I think what we want to do is grab all of these. Is that right? Key changed. All of these. And we'll do a sort of a virtual version down here. Oh wait. This. Right, so we'll get those in. E source OS. You know, I could just do this. What? Where's my gyro? Is that a gyro event? Oh, it's still called gamepad gyro. Oopsie. We'll fix that one up. Cool. Right, so these are basically just going to be copy paste of the others, different of the current ones at least, but I think the other ones will change. I also want to do a mouse. Right, so we'll just get these in quick. So there'll be a copy and paste of the current ones, and the current ones will probably change a bit. So I'll copy paste them over. Oh yeah, they won't have a device ID in these ones. Right, because they're not belonging to a specific device. Okay, let's just delete all that. And then we want to find mouse button changed. Get all of this, please. Mouse wheel moved. And then drop that in there, and then we'll go over it and clean it all up. Key input UTF-8. Do all that in there, please. And then key changed. Sorry, key changed, that's what I meant. Okay, bit of a bigger one. Right, and then we'll do the window moved event as well, get that wide in. So, okay. These obviously go to the global mouse instead. So we don't do this input device thing and search for it. We still do the clamping though, inside the window size, position. Yes. So I think the other one will take a raw input, which would be a relative mouse. So that one will change. So we're going to queue an event up. This is going to be the virtual mouse. So it still keeps the same. Right, but that would be like a null ID, I think. I don't think we've bothered to do a virtual. No, just keep the same. So we'll just make sure this is always null. So core ID null. We'll do a OS input device, something like that. ID. Position goes in here. Relative position is just a difference between those. So the device would be GOS dot virtual mouse, something like that. Right. So we've got a whole load of lots of easy work to repeat there. So we'll just go over and do all those quick. Well, mostly. Needs a keyboard, so we'll go and do those in a second. Let's go back up. So, right. That's good. Then we set the mouse state. Fantastic. This one is if the mouse button has changed. Very similar. Obviously, this device ID is now just null. We don't get a device anymore, so delete that. And we got some bits and bobs into the bit sets. It's looking good. Oh yeah, obviously I want to change this these events. Right, they're now virtual. Very nice. Mouse wheel changes that. This needs to be a dish adding summing. So add G this and that. And this should be wheel. Oh, there's a big copy paste error. Oh wait, sorry, no, I'm looking at the wrong one. Don't mind me. That's fine. Is it? Oh, I already summed it here. Okay. Right. Just getting a bit of glare on the screen. I might pull that blind down. Hey, the Devros, how you doing? Yeah, not some certain other language, and it's still you still triggered the bot. Fantastic. Um, yeah. Well, yeah. I don't know. I think, yeah. I think C++ brings a lot of extra um, extra problems. You know, if you just program in, you know, you have the whole sort of like, yeah, like the semantics are just different, and there's some good C99 features you end up missing as well. It's a bit of a shame. But yeah. Or you can try the crab language, you know. And the compile times, yeah. You know, and also you just get tempted into doing all of the super cool features with templates and stuff, and then you end up using more templates to solve your template problems. But yeah. Right, so just got to change these ones over to the virtual, right? Obviously, we've still got the old functions. We just it's very specific for this one. So we got the key code in from the event. Virtual keyboard. Oh. So in X11, is there a X11 keyboard layout per keyboard? Per keyboard? I don't think it is. Keyboard mappings. Optionally. Yeah, I think I think it's globally, which I would prefer anyway. Because it feels like it's global anyway. We can take a look in the code xkb. Oh wait, where's the OS? Yeah, we don't pass in anything for a specific keyboard. Yeah, so these guys need to not be on a device. These need to be global, which makes less stuff, which is super great. Key code, scan code, translation tables. That would be sweet. So just got to be careful and find all of these. GOS dot this guy. Very nice. Okay. It's saying there's conflicting types, no problemo. We'll just hop into the header, give them a correction. There you go. So no longer does it have to be for a specific keyboard, it's just there's one keyboard layout. Is that problematic though? It should be fine, because we'll be using scan codes anyway. Templates of templates of templates of templates. See, I guess we can always change that if it becomes a problem. I doubt it's a problem. Key code map. Right, so where was we? Yes, we're in here still. Didn't we change the names of these? No, what am I doing? Oh yeah, vert key changed. Okay. Okay. I just jumped to the wrong line, thinking I was editing the wrong ones. Good, good, good. So we're going to change this to GOS. GOS.virtual keyboard. Then we delete that, and these will be the virtual key press, virtual key released. Sweet. Now it's got to do this moved thing. So I think these are all good now. Yeah, they're all on the virtual keyboard. The device I deleted. Let's get that device thing. Device it is not, because it's virtual. So it's all of them together. So if you move a window, we want to do a new window move event. So it'd probably be like the resize, right? And we need to get that plugged in. And we'll just plug that in. It'd be very quick. Window moved. So position equal position, relative position. Now I don't know what we did for the mice. Be something like this. So rather than being on the map, so we'll say relative position equals the current position take. Now we need to get the current Windows. Okay, it's just like that. Yes. Then update the Windows state with the new location. Window. Relative position. Then you want to accumulate it. Yeah, we can have that. But then you should probably have like a relative window size as well. You know, let's delete it for now. I don't know if we'll need it. We'll see. Okay, so to plug that in, this window moved, in X11, there's this configure notify event which we subscribe to when we make our window, which I've got to go and fix some of that code actually. But there's a configure notify that you can subscribe to. And basically it says if you move that, if the rectangle of the window changes in any way via translation or resize, it's going to fire. So you want to do this. All right, so do have the width or height changed. You know, if the width or height changed, then do something. If the X or Y changes, then obviously we do a moved event, right? Position, moved. What is this? Okay, so that is S32 times 2 X. Okay, that's meant to say Y. XCE.Y. Cool. So really we should almost window resized here. We are doing a width height. We could just say dot size. Or dimensions, right? I use C++ template machine. I just keep track of this in my head. Oh yeah, let's have a look. The Intel Intrinsics Guide has a list of their throughput as a CPI, which is confusing to me. I think that would probably be better if it was IPC instead. Instructions per second. What do I do? Hmm. C XOR C++ metaprogramming. Yeah. So does this just list like all the difference, all the semantic differences in C and C++? The crazy thing is the client compiler shares a lot of code, but also has a ton of like, oh, if you're on this version of C or this version of C++, do this, do, and the behavior. It must be insane to sort of, must be insane. Yeah, they got type of now, yeah, and then there's obviously C++ is this one, the joys. Significant overlap between C, C++, Objective-C compiler, and in turn, C, Objective-C++ dropped out of that. Amazing. Yeah, I still don't understand what Objective-C++ is. Yeah, I'm using this dark mode one, dark reader. Apparently this is the best one. People was telling me it's the best one. Sometimes it will not get it right the first time, and then it will get it right and then remember it. Like it's really good at, I don't know what magic it works, but apparently it's the best one, dark reader. We changed these guys to dims. Hmm. S32 times 2 dims. Oh yeah. Just gonna drop those in. Oh, yeah. Maybe not. Cool. Right. So dims, relative dimensions, and then we'll say like, right, sub G, dims with gos.window.dims. Wait, why is it not dims? Give me the dims. Dims equal dims. Let's change that. Because the word size, I like the word size meaning size in bytes, right? So using the word size everywhere is not decent when it's multiple dimensions, right? So we're going to use the word dims for that. Oh, I closed it. Damn it. Where's the window? Sweet. What's up with these sub Gs? Ooh. No? What? GOS dims. S30 times 2. Alright, let's roll with that one. I don't know what was going on there. Right, maybe... Oh, we should correct that. Third party HCC, HMaths, libhmaths, HMath generic. So sub G ought to be good enough. So we put A in there, and it should go to this one. Then it calls AB of it. It's the assignment compatible from int. Right, what have you done? Alright, we'll just not do that. Just to save some time. Cool. Unless there's a missing comma. No. I don't know. Right. So we've changed that name dims everywhere, I hope now. Sorry, size didn't make it dims. Cool. Seems pretty legit. And so now okay, that's looking good. All right. So now we've got the events all at the ready. The next thing to do is to actually plug in xinput2 and all the original mouse events to use the new virtual stuff. Right, so go to where we poll for the events. And so this is where we did the evdev stuff, where we detect for new keyboards and mice and gamepads being plugged in and plugged out. Here we use this x pending thing to get all the x events. We'll see if there's any events worth looking at. If the queue is full, we jump out and let the higher level stuff clear the queue, and then we can get our new event. And now what we can do is actually do the event code. So we commented some stuff out here. So this is the key press stuff. We'll keep these in. These are the virtual key presses. So we'll get all these ones plugged in. Maybe it's just your linter being stupid, but maybe you should try compiling it. Sub-G and see if your compiler complains. Yeah, well, when we get it compiling again, I will do that. Actually, it's a good point. Yeah, and also the error would be better in the terminal as well. Maybe there's a way to bring it up, but I'm not that much of a Vim expert, you know. Yeah, so we're going to plug in these guys, right? So we'll just say virtual key, that. Okay. And also we'll plug in the more raw inputs in a bit. So that's just for the key press and key release. This we uncommented because it was crashing when we tried to do some X keyboard stuff. So we'll look into that in just a second. This is the fact that the mouse has been moved. Why is it doing clamping? Why is it doing it there? Oh yeah, sorry. I just realized. the comment's saying, right, because you want the relative position to be nothing. Yeah, it's a bit of a hack. Let's look at the X crossing event. There's no relative from, yeah, there's no relative X. It's only like where the pointer is in the window, so you don't get a relative X and Y. When this is using the virtual mouse, right? Not using the raw events. So we have to get the relative ourselves by just doing a difference, right? So you do a difference like this, right? From the one you've already stored to the one that you're passing in. So we simply just we store the one and, set it to the current one. Yeah. So this is when we enter. So the focus has changed, so we get mouse focus, right? Mouse moved. Why should you have two? Oh, virtual mouse moved. Right, mouse focus change that we left. Yes. Focus in, keyboard focus change, yep. Next, button presses is the mouse buttons. So we're just going to go ahead and re-enable that. So that'd be virtual mouse, re-enable that. So this is the generic event, which is used to sometimes do extensions. xinput2 uses this generic event, and you have to do some stuff to figure out if it's an X input event, and then do some more stuff, and then realize it's these X input key press and stuff like that. We'll be looking at this in a minute. Let's just get the old system wired back in, and then we'll be doing the raw input stuff. Yeah. Right, so let's take a look at that. So we've got in the main file, we do have, oh my days. Shouldn't be conflicting types anymore, we'll look into that. Let's go to this stuff. So what we want to do, dims.x, dims.y. We also want to do a moved one, right? So this obviously can get really crazy, all these, especially when you plug like a gamepad in and the analogs are going like crazy everywhere. So I know where we've moved the cursor, window. Cool, so all of these guys, want to copy these, and then want to put them down. Oh, wait a minute. Oh yeah, there's gyro and stuff like that missing, right. So we're going to do a virtual ones, right, vert. Just go through and get these in, so it's like type. So we type vert. Very cool. So we'll go ahead and say vert, 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 vert. So no input devices. Bearing in mind, these guys should be telling you the input device that is firing. Yeah. So you want to be like input device. You could do the full string for the name. It gets quite long though in cases. So we might just do the ID. So just do a hex thing for we'll just do a number for the ID. So just be like event button, mouse button, dot input device raw, something like that, right? Just drop those here. And text input, there you go. So we'll try multiple keyboards and mice, see those happening, right? So we'll be plugging in today. Cool. Awesome. So this is the high level where we can test it all out. Hey there, the idea of Alan. How you doing? Welcome, welcome. How's things going? Welcome to the stream. Have you had a shave for the midwife? Yeah. You know, when the baby comes out, I'm sure there's tons of photos and I'll have no time to leave my wife and get a haircut. So it's a good time to look fresh, Perry, you know. So did a nice shave. You know, I still don't have any templates anymore on my shaver because I broke it. I think I did one of those backflips with a shaver and it fell on the floor. And you know, just the plastic broke. So I was just freehanding, just shaving it to try not go too low, you know. But yeah, how's things been, Perry? The baby is any moment now. Its due date is 1 week away from today. But the belly's so big, it's just, you know, it's gonna blow any time now. So, soon I'm gonna be a papa. Looking good, mate. How's mama getting on? Yeah, it's doing good. Things are getting a bit heavy. The baby's 3.2 kilos. So yeah, that's quite a bit of weight on your belly. But yeah, she's doing good. Just we're just wanting the baby to sort of come out, you know, so we can think things are a bit easier, you know. Thank you. But yeah, I'm looking forward to the baby coming out to get to see what it's like, and then also do something different for a bit, you know, like figure out a baby rather than programming. You know, and sleep at really weird times. He was about 4 kg when he was born. Nice. Yes, that's big. Big baby. Yeah, I think I was about 3.2 myself. And I just grew vertically, you know, vertically fat individual. Let's press some F5s and get stuff compiling. You got the mastering C pointers. You got the mastering C pointers ready? No, I haven't got that gem of a book, unfortunately. Yeah, I think they might start on 6502 assembly. You know, that'll be their first computer language. You know, the essentials. Not too many stuff broken. Oh, this is Vulkan code. Ooh, I changed the Vulkan thing. Right. I just remembered before we get this thing compiling and run. Before we run this thing. Yeah, before we run it, the way I've subscribed to events is a little sketchy at the moment. So when we create the window. Window open. That's it. Oh no. Open window. Wait, it's got to be in the OS side of things. Okay. OS Linux. That's what I meant. Right, so I changed how this works. Oh no, it's the xinput2 stuff. Right, when we do xinput2, which is to do with the raw events and stuff like this, per device, we need to look at this again because currently we do it on the root window, and I don't know. Yeah, we'll have a play with that. Because if we do it on the root window, it comes out of this function. If we do it on the window specifically, it stays in this function. So we'll see. Is this IntelliJ WebStorm? No. There is no web No web. Zero web. Okay, let's give it a run. Let's run our web browser. Right, so obviously got a black window because we've disabled the graphics. Not that there was much good graphics anyway, but see, I pressed the enter and it showed up. I'm moving the mouse and we get a bunch of xinput2 stuff, so we want to disable that print for a minute, you know. Oh, we disabled all that. Come back. Oh, I'm glad we sorted this out. Oh, this is good. So good. Oh my days of contacts. We're gonna go look at the git log and make sure I'm not. Because I disable all this keyboard mapping stuff. Not good. Right. Oh yeah, it's back. So xinput2, so it's like x event, xi key press, all this printing stuff. But we'll bring it back, right? We just want to, you know, this is all in here to sort of, you know, we tested this at end of last stream. Okay, good. So if we move the mouse in here, it doesn't really show up. Shows that it enters and it moves thing triggers, but not when you move it inside. So clearly we've not plugged in the, see what enter and leave for the mouse focus, but clearly the mouse moved event is not being called. Okay, we missed this one. Okay, let's give that a go. See, we flip the y-axis here, yeah. Because we're bottom lefters, x11 is a top lefter. There we go. So if I go up, you see the relative. See, here's the relative y, relative x, and then here's the absolute coordinates here. Obviously x, then y, right? So if I go up, the y is positive. Down, the y is negative on the relative here. Then left, negative, right, positive, right. So bottom left is 0. See here, this thing here, basically 0. Up here is the width of the window, and voila. So we can click, get some mouse buttons. Oh, it's telling us that it's the event device node thing. That is an xinput thing we've got to get rid of. But you've got the right click and left click back in, got the scroll wheel. Oh, we didn't get the scroll wheel back in. Yeah, we'll look at that. Where's the scroll wheel? I delete my scroll wheel. No, that's the mouse button. Ah, wheel. Virtual wheel, please. I need you. Right, so I'm gonna give it a bit of a scroll. That works. So down is negative, up is positive. So the press keys, right, we got, I'm using a Comac keyboard layout. So we have a key code, which means the physical key place, and virtual key code is meant to be the mapped version. So if I scan over where QWERTY is on my keyboard, right, you'll see that it is, okay, let me leave my mouse out. Okay, that's fine. So you got Q, W, E, R, T, Y, and then U after that. Then obviously, respecting the Comac keyboard layout, it is, wait a minute. Oh, released Q. Yeah, sorry, okay, sorry, it's fine. But the virtual one is, yeah, Q, W, F, P, G, J, because that's Comac. So yeah, we've got virtual key codes if we need them, but probably not too much. We've got key modifiers where you can like press the control key and you'll see that it's telling you that the control key is pressed, control shift, alt, right? Also got key repeat, if you hold it, it repeats. So if you use multiple keyboards, they both fire this virtual key event, but then we're going to have a raw one which is specific for each keyboard, stuff like that. Awesome. So I'm glad we plugged that back in and everything still works. This is where we were like on day 1 of all of this. Now we're like day 6 or whatever. I kind of forgot because we went on a big detour to get gamepad and multi-keyboard and all of this. So we're just plugging it all back in. So it's coming together now. Excellent. What the hell are the 2 volumes? What the hell? There are 2 volumes of Mastering C Pointers. Yeah, I didn't know that. I thought there's only 1 book, but yeah, there might be 2. Yeah, it's just a very terrible book. Hey there, Basandrew. How you doing? It could be Emacs. You never know. Nice. Could be fooling you all. Awesome. Right. So I'm quickly going to get another cup of tea. Get a nice tea, see? And then we'll be plugging in xinput2 to be able to do raw mouse events for individual mice, so multiple mice using this guy. And then obviously the raw keyboard as well. Sweet. And then hopefully we'll get to some gamepad stuff. Be excellent. Right, I'll see you guys in like a few minutes. I'm just going to boil the kettle. Enjoy the tunage. Right, hello everyone, welcome back. How are we all doing? How's things going? So has anybody got any questions regarding what's going on? Or if they're missing any information about what we're doing? Or just want to ask anything about the projects, really? You could put all printfs in a debug macro. Yeah, the issue with just doing it under debug is it's just very general. It's general debug. Whereas I probably want it to be like debug key map, right? A very specific thing. But yeah, good point though. I could give it a proper thing. But also, I could have a config file, right? And maybe we have it as a runtime thing instead. Why not Wayland? Because I'm a X11 scrub. Yeah, maybe Wayland. You know, I'm running X11 right now. I've not bothered making the jump because Wayland has never. It's always nearly been ready. But yeah, it'd be good to try out the technology and see how, if as a user, do I feel anything different about my desktop? Because right now, oh sorry, besides the screen tearing, right? Because the screen tearing you see all the time. I'm using Gentoo, no, using Manjaro Linux, so it's Arch based. When Wayland, Mr. Dick still, eh? When? Well, probably not for a good while until, you know, until it's probably. I'm sure by the time I finish this thing, Wayland should be at the ready. So maybe we sort of switch over there towards when it gets ready, you know? Yeah, the question, what are you doing? I didn't join the beginning of the project. Um, so we're currently making a game without an engine from scratch in C. Um, we've just done the graphics abstraction or our GPU abstraction so we can do graphics code. We've come down into the engine because I neglected it. So we've done custom allocation, got custom collection classes like dynamic arrays, hash table, and object pool. We're going to be doing a UI thing so we can do UI for our game. And then the ultimate goal is to do our own rendering, research and development to find something unique. And we're going to be using compute shaders only, no triangles. Yeah, just raw compute. So it's technically going to be software rendering, but using the GPU to do that. So that's the project so far. After that, we're going to be making a game. And that is going to be figured out when we've done the graphics R&D. Why is there a triangle? I know. Isn't the screen tearing issue with the compositor? I don't know. I think it's so it doesn't show up on my AMD machine, but back on my Intel laptop, it was screen tearing like crazy, and I think it's just an inherent. Well, I don't know actually. It could be the I don't know. Yeah. I'm not sure what it was. Like, I'm not sure why the issue exists, but I know that X11 has screen tearing issues a lot of the time. But it's not. But it is avoided on certain setups of hardware and software. But yeah, I'm a bit unfamiliar on the exact thing because I remember when I used to plug in the HDMI cable and watch some live streams or some videos on you know some streaming services, and it used to tear all the time. They're like do a horizontal pan, and it would just be terrible. You know, what's the game about? We don't know yet. I'm not going to bother testing that. I'm not going to bother trying to figure that out until because I'm going to be wearing many hats, and I think I want to like hone in and focus on a specific area at a time. So the current area right now is the code base. I need a minimal code base just to do R&D for graphics. Obviously I've gone a bit of a detour here doing gamepad support on multiple keyboards and mice, But I thought it'd be a bit of fun, and it's something I haven't done, and it'd be good to learn. And I'll add a constraint later to the game design. Right, I want to use this feature. Um, but yeah, when as soon as we have the graphics R&D done, and we can visually see like this is this is a some form of like rendering tech that we want to use. Um, how how can that impact the game itself, right? Um, and be a lot easier to see. A lot easier to use that, and then I can focus on game design, right? There's a research and just really focus on that. But yeah, I'm not sure if I want to, because if I did that now, my ideas will probably change. So I want to be, have it all fresh in my mind when I start, right, and have it all figured out. Obviously, the game will evolve. There will be unanswered questions, but there'll be a general direction I want to go in, basically. So you're on the game engine right now, kinda. Yeah, not a general game engine, but a specific one. Yeah, I'm not sure why it is. No, it's really weird. Like it's notoriously known, and some people, from what I remember hearing, was that Wayland fixes all screen tearing issues because it's something to do with the design of X11, but somehow they get around it sometimes. I don't know. Yeah, I think you get VSync issues occasionally on any hardware. I'm not quite sure though. What's my inspiration? Well, since a young age, I've where like why am I in this place where I'm at right now? Well, since a young age, I've always asked, always been interested in like why or how things work, and it's always like it's quite an endless journey. But I started off doing JavaScript, and then I just wondered, I wondered what it was like to do more low level stuff. I tried it, and I was like, this is really hard. And then I remember saying to myself, well, I'm not going to be doing, I'll just do JavaScript. The very very defeatist attitude. Um, and then eventually got around to doing it again, and it was much easier, right? Like understanding what is a pointer, that was really hard. Um, so I've always been interested in understanding how things work, and that's why. Um, so that's a big drive. But writing a game engine right now. So yeah, so that has very naturally led me to like wanting to write my own sort of engine because you know I could just use Unity or Unreal, but whenever you use their tools, there's like a workflow you have to learn, and there's a workflow that's imposed on you. Um, and it would be great if I could make my own workflow and have my own constraints that I impose on myself. And learn how these things work under the hood and be able to make the best decisions when I eventually make something, right? And also it's fun. I was saying I like learning about it. Um, and, it'd be great to you know but yeah, what about physics then? I wonder if any physics, right? Just see what happens with the game design. But yeah, I don't know. Like just using other game engines as well. Like you were just, I remember trying out Godot, and I was like, this scripting language is just, it's just horrible. They're very limited and it's very nice with the documentation it had in places and the way, but ah, but yeah. Obviously, seeing that has its problems, but when you can make your own API on top of it and just forget about it, always good. Or on top of the OS, I mean. GD script. It was GD script. GD native wasn't around back when I tried it. Wayland rocks. It's nice to write code for, especially now when you have one. Oh, the Chat GPT document Wayland. Oh, excellent. Yeah, I've seen some examples, but yeah, again, it's code I haven't programmed yet. But then I did encounter that issue when I did this xinput2, a few streams ago. I just spent ages looking at how to do this. For a C programmer, you would think the first thing is to try and you would try the Unreal Engine. Well, not really, because the Unreal Engine was built for like first-person shooters, and it's quite general, and it just solves all these engine problems. As a C programmer, you might want to talk directly to the operating system and do stuff yourself, or have more control. Current state of Rust engine, game of engine-ish. Sweet. Oh, your one. Excellent. Let's take a look. It's got like the Halo wagon and the the Warthog. No, it's not the. Nice. This is carnage. It's pure chaos. Look at like a spider. Oh wow. You got like what is that? Inverse kinematics, isn't it? Something like that. Where you're nice. Kudos to you, sir. Where you're able to sort of like check where it collides on the terrain and then procedure animation, right? Very cool. Have you got your own physics engine that you're doing? Nice, very cool. Good stuff. What did you just make this? Just Rust. This is one of the most talented engine engineers I've ever met. Good comment. And then you'll get someone like crapping on you down here. Usually, that always happens. So someone's like, "Oh, this is more impressive." Like, if it did this, it'd be way more impressive, But you don't seem to have any of those comments. So kind of rope but handles vehicles in there. Springs fine. Sweet. Very cool. Impressive stuff there. It's pretty great. Have you got any ideas of what sort of game you want to make? Or are you just getting the tech together still? Obviously FPS, I guess, right? And you can get in vehicles. Yeah. Plenty of better engines in C++, but the experiment here is to get one done in Rust. Nice. Just in case. Throw stuff in, see what sticks. Yeah. Oh, just in case of friend stuff in C++. Okay. Fair play. How you pronounce Godot? It's Godot. It's not Godot. There's no Godot. Right, so xinput2. So when we create a window, we need to subscribe to some events. So ultimately, we don't care about. We just care. I think we just care about the raw stuff. Now I think the raw motion. Button press, button release. Yeah, we want that. What else can we get raw? Can we get raw? Oh, raw button press, raw button release. Yeah. So everything raw, right? No enter and leave. I don't care about that. I don't think. Take a look. Enter event. So you can tell with like different mice. Yeah, we don't want that because we don't. Yeah. I think the standard enter and leave are just fine. Key press, key release, button press, button release, raw. See, I want to. Huh. I don't know how people do the gesture code, you know, with gestures and stuff. Like, to me, that just feels like I don't know how to solve that problem. I can think of complicated ways of solving that problem, but simple manners, it seems weird. Right. Yeah, obviously swipe is easy, right? Swipe's easy, but more like with the draw stuff. It's French, to be fair. Yeah, I know. I know. Lean me, Majine. How you doing? Welcome back. But yeah. So we did root window because I think the raw events didn't work on the on a regular window. I think it had to be on the root window. So let's try that out. If so, we're just going to move it outside, right? So we've got raw motion. We brought it all back in. Let's change this to W, which is just the X11 window, you see. So let's just fire that off. Okay, the game crashes because it's got bad value. It wants to be the root window. So because of that, what we're going to do is we're going to take this, I'm going to put it next to the XKB code, which is when you boot up. Like that was when you opened up a window where we just saw. But what we really want to do is put it by the. There you go. Just when we initialize the actual X11 backend or Linux backend with X11 bells and whistles, xinput2 extension, just do raw events because that's all we want, and we'll roll with that. Let's fire that off. Okay. So we're getting all the printing coming out now. We've got this event node 15, right? So event node 15, we need to that's where X11 is reading its events from. So if I were to do ev test, I've got to do a sudo, right? Dev input event 15, right? If I move the mouse, can you see I'm getting all this relative X and Y stuff? And this is what the X11 is reading for us. Now, notice I had to use sudo to access that because obviously you don't want any device just simply accessing it. Any user, rather, sorry. You want to be, you know, it to be somewhat protected. So you have to use X11 to get it. So that's why we're using xinput2 to get access to the raw motion. So it's right. So what we got is when we get our raw motion event, we get the property for that device node, right? So we use the device node atom. So the atom is a string deduplication. So we have this device node string. We deduplicate it into an atom, as it's called. It's like a string ID. And we get the property. So it's a property of device node from this, which one is it? This is all very heavily, or sorry, very terribly indented. Just got to figure this all out again. Device ID. Right, so given the device ID from the event, can I get this, right, so we might have to tidy this up a bit. So I think let's just write the code where we can, yeah, let's write the code and plug it all in first, and then we'll come. Actually, no, let's just clean it up. It's just, it's horrible, man. Atom type. No, it's not atom type, act type, I'm not sure. Right. Data, alright, be fine. Yeah, okay. I'm not sure what else I can really do about it. I think I might do something like this actually. Yeah, let's just do that. There we go. Bit nicer. So we're checking to see if it's got this device node. Right, if device ID has device node property. That's all it's doing. Then we ensure it's a string, right? We're just being a bit safe here. And if it's simply not that, we then just ignore it. So this is the device node, const char star device node. So we need to check. So that'll be like event 15. Now we need to go over all of our events. Input event, sorry, all of our input devices, and what we need to do is find, so we need to do like an iterator. We'll go over all of our input devices, and we're going to find the one with that thing, okay? What's so difficult about pointers? They just point. Yeah, I don't know, like when you're coming from other languages and you don't do much, you don't know much about memory, like understanding a pointer could be quite difficult to understand, because especially when you're learning C, a pointer is used for an array, a pointer is used to reference something on the stack, a pointer is used, they like add to a pointer and they like array index a pointer, they have double pointers and, you know, function pointers. You know, there's so many different variants of it, and how you use them, that it does seem a bit confusing sometimes, especially when you see like old school C code, you know. So I can see why they're a bit of a hard for people to understand. Unsigned char A. Cool. So we kind of want to iterate over all of these. And you only really care if it's got a probably if input device features, maybe the mouse, right? OS input feature mouse. So if it's not got a mouse, we'll continue. Why else would you want to skip this one? Hey VMT, how you doing? Yeah, it's the wrong stream. How's it going? How's things been? Yeah, so we want to do a string compare now. So we need to get the input device backend. Linux input device. So basically, like, we've got this structure where it has all the device nodes, right? We simply just need to do a check. If string compare input device backend and mouse dev node is equal to device node, then we've found ourselves the correct thing. Now, notice I'm doing a string compare here. It might be, there's actually not too many devices. How many mice you can have plugged in? Probably one at most. Obviously, you could have multiple if we're doing a game design around multiple. Be a 4 maybe at most. So maybe the string compare is not so bad. But yeah, you could probably hash it if it's a real problem. So now at this point, we can break because we've found the device. And then what we want to do is actually do the event now, right? So this is a mouse motion. Mouse moved. So it's not the virtual mouse, this is the raw mouse. So we need to pass in the input device here. And we give it a position. Now that position is kind of a lie. What we kind of want to do is give it a relative position. Okay. And we don't care about it going inside of a... Ooh. Yes, that's interesting. So I think every mouse in that is going to have a position inside, and maybe we'll have a way to reset it. Oh. Oh, you're showing a Nico's bot. Good anyway, so did you end up with xinput2? Yeah, we're just plugging it in now. So we ended up with xinput2. Let's do the multiple keyboards and mice. Although we had to have to do a string compare to map it. But yeah, we used evdev to figure out all of our devices. So we use evdev. So here's my little test program I wrote to sort of dump everything. So we can use evdev. We look at all the USB devices attached, and we look at all their child devices, and we can find these event file descriptors that we can read from. Obviously, we can't read from mice or keyboard. X11 does that, but we can use that to map to the one that X input tells us it is. We'll end up using these event file descriptors for the gamepad though. So yeah, we'll be getting to that today, which would be good. But yeah, it's going good. It's been a bit of a detour, I think this has taken us long to do, or longer than doing the graphics thing we did, or the GPU abstraction. But it's stuff I haven't done before. But I am really liking the abstraction we've built, and I think it'd be very joyful to use, you know. Or I don't think I've ever had any more than 2 of them plugged in. Yeah, this is the fun, Perry. Um, the game, the game can have multiple keyboard and multiple mice plugged in, and game controllers with trackpads on or multiple gamepads. So the fun will be, yeah, the fun will be like, you know, I'm hoping to maybe in this game have couch co-op, and you can plug in multiple devices. Maybe it's just multiple keyboards that'll get used. Yeah, just having the freedom to just plug in all the accessories you've got would be a bit of fun, and not be limited to just one keyboard. Hmm. Yeah, I'm not sure how useful like multiple mice is. Well, you could be doing a first-person shooter, right, and having 4 players with mice and keyboard plugged in because they want to. It's possible. Yeah, use up all USB slots. That's why you want to get a keyboard with a USB in it. Yeah, and daisy chain them all. So I think what we want to do. Mouse position. We should have the ability to warp a mouse, right? Should we? Warp a mouse? Maybe I don't need it just yet. But yeah, internally we're going to be holding our own mouse position. So what we want to do is position equals this. Then we want to kind of offset it with the relative position, right? Because we're using raw input. Be your relatives. So we add. I got to try that sub G thing that errored actually. We'll do that in a minute. I forgot. Right, so this clamps it inside the window bounds. Yes. Relative mouse. Relative X and Y might have to get flipped actually. I will sort that out in a minute. This is mouse moved, new position. The relative position is rel pos and rel pos. Wait, accumulate rel pos. Excellent. Excellent. Yeah. Linux. So yeah, we'll give that a go. Hopefully that's going to plug in and give us a mouse moved event as well. So we'll get rid of all that. Wait a minute. We didn't get the raw values out. Let's get them out. So the raw value. So this is coming as a double for some reason. So we'll do a. Should we do a round or a? We'll do a round. Round. It's just called round, right? Then we want to say, s times 2 rel position. Cast that into a S32. And then you want to copy paste, change it to a 1. Do we need like math.h or something? Good old math. Math. Okay. So hopefully that should be all we need to hook it up, right? So every single time we get one of these raw motion events, we get the property for device node, we look that up when in our input devices, obviously skip the ones that are not mice, and then we get the X and Y coordinate. Sorry, we check to see if it is this mouse. If it is, get the XY coordinate and then make the event. Sweet. So let's give that a run. So when I move the mouse, we've only got the virtual mouse moved. Can you see that? It's vert mouse move, which is not good. So I guess we need to do some printing. So I'm going to print yay if we're in here. There's no yay. Not good. Let's print a yay if we are here. Wait. If we get here. We got some yays. So we iterate over here. Okay, so maybe this dev node pointer is wrong. Use the A method. That's good. I love a good EA. Oh, except it's high. Yeah, I used to have a macro called like I'm here or debug I'm here. And it will print out like the line number and file when you get there. But yeah. Hey there, Type Beaver, how you doing? Oh, dev type? What are you talking about? What is that dev type? Right. So these could just be fixed things, and remember, you know what, it could be a lifetime issue. Guaranteed it's a lifetime issue. Oh no, it's not. Yeah, it is. Yeah, I think the memory got reused. Guaranteed it got reused. Should we have a bit of a try? Let's have a bit of fun. Wait, is there a way to do this? Wait, do you do like T to open up in a new window, I think? So I say OS Linux internal. No, I can't get it to open up in a new. I forgot the shortcuts. As you get older, you trust farts less. Wise advice, Perry. Wise advice. You need to eat more of those salads, you know. So right. Ignore me for a minute. I'm gonna JavaScript. Do dev event. Wait, input event. Let's say like 100, right? It's probably most digits you're gonna have. All right, 19 plus an old terminator is 20. So we try this out. Type Beaver. Oh no. Need to eat more salad, Type Beaver. So we're going to do a string copy. Obviously we should do a more safer version, but let's just do that. DST. Wait a minute. Here we do the string copy. When it actually gets selected. It's const char star. I need char star. All right. What is this? Oh, it's changed. Crap. So 20 bytes. So difference of 12. So this needs to change to Difference of 12 rounded up to the nearest 8, right? So it's just 4. Cool. Anyway, what was we doing again? Yeah, we're trying to see if this prints out anything. Oh, did we? 12, 9, 7. Did it mem copy and fail? Yeah. Clearly. Alright, if... So I wanted to see if this device node, if we... Now it says manufacturer. Why is my device a manufacturer? Like what? In what? So the problem is I got device node, and it must be giving you an internal pointer to some temporary buffer that as soon as you use it for call another one, it will overwrite it. So the last one's obviously manufacturer or something for some reason. So that's not good. So really, we actually want to do a little local copy as well. So we'll try that. And obviously we won't hardcode 20s everywhere. We'll put some, put it in do a thing. But for now, let's just do this, right? So string copy. So we're saying if feature, device features, yep, and OS features mouse. Look at that, IntelliSense is right on it. Recompile that. What do we get? Right, now we get something sensible, and now it's showing up. Look at that. So we've got our, although the mouse move is not giving us the device ID like I thought it would. I forgot what but anyway, it's showing up event. Okay, so it's just a string lifetime error. They're all pointing to the same place probably, or some kind of place. Okay. Yeah, so I could go and change to using this. Yeah. Alright, let's quickly swap over to using this, although I could have sworn mouse moved. Oh, are you the only one I didn't put the ID on? Oh, you're missing out. And these all shouldn't be mouse button either. Mouse moved. Mouse button, that's fine. Mouse wheel. This one is key. Text input. Oh yeah. Cool. Right, so we'll see something proper now. But we should probably handle this properly. But I think this might change again in the future. Because I think sometimes the accelerometer is shared between the gyroscope and the... Yeah, so I don't know about this fully. So we'll just, for now, we'll just do this quick define. We're going to say OS, Linux, dev node, cap. So we'll say 20, and we can say like, supports 3-digit event node. Plus the null term. Okay, whatever. Before switching to C++, my engine jumped from less than 10-second compile times to 45-second compile times. Yeah. Wow. Yeah, switch back to C, my friend. And ditch the OOP and the templates. C is the way. When you see, you will see. Yeah, C++ is crazy. Dev input event 100. Right, on 999. There you go. Support a 3-digit event node. There you go. Okay, so just drop that in there. Right, so we'll ooh. Now we've got to make this a bugger. Damn it. So I've upped it by, so it's on 60. So how many 12s are we adding? 5 12s. Right, 5 12s are 60. Right, maths. So it's just another 60. And is that round up to the nearest 8? It is, good, I think so. Right, so now it's got to change these. This is when we register a device. When we're trying to add a USB device, we search its child devices and find its capabilities. So we're just going to do the same thing again here. Linux. That's good. Plop that on there, plop that on there, plop that on there. Oh yeah. Okay, so we're just gonna copy a string, copy another string, copy strings. Yeah, so if you're copying strings, technically it should be safe. You know, maybe if you plug in like a thousand devices, maybe it won't be safe. For projects that don't require user interface, C is really lovely to work with. But for UI code, C creates all problems, having to keep function pointers around, doing stupid casts and emulating OOP. I don't know, man. Like, it's because you're doing an OOP style thing, right? If you're doing OOP, like then obviously a language with OOP is going to be better, but you don't need to use OOP to do UI, right? Like that's my point. It's like you don't even need to do immediate mode UI to do non-OOP UI, right? You can do something different. Like I think did Nax do a thing where it was more sane, sensible UI? You got to try and use Google in the age of 2020 whatever we're in now. You know, he did a blog. You got to dig it out. Because things like rocket science. Now apparently, but he did have a blog for his UI. You have to dig it out. It's somewhere. But yeah, he made this thing called Luigi that he uses for that GF program, right? That graphical front end for GDB. And he's got, you know, so I guess I'll link this, right? This is not OOP from what I understand, right? Take a look at that to get some, you know, it's all in C. And that's not immediate mode, that's retain mode. But he has got a blog, but it's like, you know, Googling for stuff nowadays is difficult. What was his blog on? Was it on GitHub Pages? Or was it... I think it was on GitHub Pages. I don't remember. Does anyone remember it? Oh, Yandex. Yeah, but I only heard about Yandex the other day. Ooh, like Google used to be good, man. Um, where's his UI blog? Was it like a? Maybe he's got like a GitHub pages or something. And you gotta not do that one. Or like a Git wiki or GitNub. GitNub. My face. This is it. I found it right in a toy UI thing. There we go. It's got like all these parts and stuff. Like I want to take a read over this because I want to look in. Like, so I've done immediate mode for so many times, and people. Anyway, I want to try and sort of see retain mode or not. So anyway, yeah, that's the one. You got it, VMT. There we go. We've got it at the same time. Damn it. Awesome, good stuff. But yeah, that was so difficult to find. Buried. Anyway, I'm gonna keep that one open because I actually want to read that. Thank you so much. Appreciate it. But yeah, read over that and see if it gives you any ideas because yeah, C++ is obviously going to be better for OOP, right? But OOP is never great at solving any problem. It's always average it's always okay at best, right? Basically. But yeah, in general, UI code is always messy as well. All right, let's get these all switched up. How did OOP get so popular? Clean code, baby. Oh yeah. OOP got popular because it got taught to students. That's why it got popular. Like, what gets taught to kids in school? Turns out everyone knows, right? 2 plus 2 equals 4. That's why everyone knows it. Okay. Dun dun dun. I found issues with immediate mode because I want to do all my state updates separately from the draw function. Right. Yeah, you do immediate mode in 2 passes. Basically, with that, and I think Ryan Fleury has a blog post. I can give you a blog post as well, right? Fleury, I don't know spell his name. That one. He's got a blog post on how you build immediate modes UIs, right? I think it does do a lot of rambling, but that's what blog posts do. Yeah. But yeah, the concept is right. Is basically a media mode UI is the interface, right? But inside it works more of like a retain mode UI, and you basically do it in 2 passes, right? You do steps in 2 passes. Like one pass is to update the tree and make sure your node exists and has been moved into the right place or removed for that widget and does any logical things. And then the next pass is go over the whole tree and render it. Obviously, people will say that's inefficient, but yeah. But there is probably a different way to do it without doing that, and making it more stateless. But yeah, just gotta have a bit of a play with it really and see how to fix it because I think people had too many bad experiences with OOP APIs that are badly written and got hurt. Bad memories, bad code bases, etc. Yeah, that's it. 2 plus 3 doesn't equal, yeah, 4, it doesn't. It could be anything. Anything you like. Because there's no objective truth, is there, Perry? You know? There's no underlying truth anymore. Yeah. I don't know. OOP's always been bad. Like anytime when I try and solve a problem, I'm like, you know what, this is it. OOP is the best fit. It never works out, you know? Like a recent example was a scene switcher for like a game. Oh, I'm in this scene, I'm in that. I'm on the window. I'm on the title scene. Oh, no, I'm in the games scene. And you're pushing and popping on a stack of these virtual things. But then I think like a tagged union worked better, or um, you know, just summon. There's other techniques that just worked better. And I was thinking OP's, you know, this is it, and then it just wasn't. Unfortunately. Yeah, yeah. It's just a strange thing. OOP. People choose it to solve every single problem, and yeah, I guess it's great if you just want to follow something blindly and have it all consistent. Um, do 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 do. Oh, I've got more assignments. Right, I think that's enough. Copy pastes. Trackpad or touchpad. Oops. Gamepad. Accelerometer. Gyro. Right, so make sure we get these mouse ones right. So touchpad. Keyboard. Gamepad. Accelerometer. Gyro. There we go. I think these might be under the same one, but anyway, we'll see about that. Okay. So I think that's sorted it all out. Good. So we've done the raw motion, right, from the xinput2s. Now the next thing to do is what about raw key presses or something? What is it? Key press, key release, and button press, button release. Okay. Let's do that. Oh wait. We didn't flip the y-axis, did we? Should we take a look at that? F5 that one. Oh, wait a minute. C++ in multi-paradigm. Yeah, I would say that. For scene transitions, I handle that outside of the scene functions in a global loop, so I don't get an update step. Also from scene, I handle. Okay. You feel like people use OP all wrong and then blame OP for messing up. Hmm. I don't know if that's true. Like, I use OOP in the most simple case, and then it ends up being wrong. Like, the fact you can't use OOP in the most simple problem, like, or in a complicated problem, and if it turned out right, just seems, yeah, it's got fundamental issues. Fundamental. So anyway, I'm going up. The relative is invert. Okay, see this relative here on this right hand side. Bear in mind here, there's mouse moved and there's virtual mouse moved, right? Mouse moved is this specific device, whereas virtual is like the combined, them combined, right? So if we go up, it's going negative. That's wrong because we're bottom left origin, so up is increasing. So I just need to flip that. All right, so we just do a nice little negative and voila. Fixed. There we go. Cool. Yeah, so it's got like a position and that all gets updated. So the mouse cursor is actually moving around in here, but just getting trapped inside. When it comes to the non-virtual one. Sorry, the raw one. Yeah, maybe this the vert mouse is a bit confusing. Word virtual. Maybe we should call it something else. Rather than vert mouse. Like, this just means like the system's mouse cursor. No. It makes sense. It does make sense. Okay, what's the next thing you want to look at? Yeah, so the fragmentation as well, and how you allocate those things. You basically have to write a good low-level allocator if you want to get it to be next to each other in memory. But then you can't do a simple array index anymore, and you have to have an array of pointers to map to that. And do you not basically implement OOP with structure-based methods? Yeah, but that's not OOP. Virtual methods, inheritance, encapsulation. That's OOP. Like, we do encapsulation, right? But we do it at the sort of we do it at the subsystem, the system, each subsystem has encapsulation, right? So as an example, we've got this OS, right, Milton time. Dun, 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 dun. We need more boxes. So anyway, OS. We've got this os.h. There's like an implementation. C rather. And there's also a sort of like internal header. OS, I'm going to call underscore, but this is like the internal one, right? And that gets included by this. And also there's implementations like OS, Linux, and Windows and so on. These all include this one. And then this one obviously gets included by that one. So basically, right, you don't want, like, we kind of have encapsulation, right? We're hiding stuff. We're putting stuff behind these sort of functions that we call to get, using this sort of input device ID to get the position or the relative mouse position and stuff like this. And if we hop inside to the internal header, we see the actual structures of these things, and how to get the input device, and it's all the internal workings. So I think at a system level, encapsulation is fine because it allows you to like define an API that you don't want to change. But doing it at a per structure level, I don't think is the right place. It's it's just better if it's at a whole subsystem, basically. So we see what this global here with all of our stuff. We've got like a pool of input devices. Yeah. Yeah, like another great thing as well is it's not, we have this in a header called OS internal. So even the code base, if I'm like, oh damn it, there's just too much abstraction in the way, I just want to get access to the raw stuff here. But it shouldn't be anything that we like just to prototype stuff, right? What we can do is we can include this internal header in that other place, test it out, get the thing working. When it works, we can go and do a proper version later. But so it really allows you to be to get around this encapsulation thing, whereas OOP will forbid you from even trying any of it, even though it's right there. The field is right there, right? So yeah, encapsulation is good, but the way that OOP wants you to do encapsulation, in my opinion, is a bit too the scope of it is a bit wrong, right? Yeah. Yeah, the problem is many people don't understand what OOP actually is, and just get taught OOP is, you know, they still teach it in schools, so. Yeah, but it might have been written using Java, but is it really doing all the performance intensive stuff? You know, all of the stuff that's really performance critical, like is it drawing every pixel? Is it, you know, that's all done by the GPU, isn't it? Right. Um, Right, so I think that's a good thing. So the next thing is the mouse button released and the pressed. So let's hop into. So we've already got a button pressed and released from the old school API. We're keeping this for this sort of virtual cursor. This is the operating system cursor that you move around. That we have the ability to hide and show, which I haven't tested just yet. We'll hopefully get to test this soon. So I just want to find this code here. We just want to rob it. And all we're going to do, I'm just going to repeat it. We could share it, but you know. So we need to check the cookie because that's what it's called, is a cookie for some reason. I think we'll delete this key press key release. Delete that for now because we've got raw motion. Okay. So wait, how's it look for light? Should be better. So button press, button release. So we need to make sure we use this cookie ev type, the event type, and we need to make sure we are. Let's just double check. XI button pressed or XI button released. So easy to do copy and paste errors in this. So we've got to figure out how to do the button. Let's go into the xinput2 header. So there is like a raw Raw key press. Okay, what about raw button? Oh, it says raw etc. So it's all in raw event. So detail must be the button, basically. We'll have a bit of a play with that. By simply, wait a minute. So let's get the button. We'll just call it int button, I guess. Or is it an int? Yeah. Everything's an int. Raw event de, device event, detail. So we're going to print out the button, and then we'll just have a bit of a play. Now, we're just going to comment this out. Let's test it all out, you see. We'll finish it off. So, okay, I'm going to click. It's saying button 1. If I for the left click, right click, 3, middle click 2. I've got the back and forward buttons, 9, 8 and 9. And I've got the scroll wheel, 4 and 5. Okay, that's good. Yeah, so 4, 5, okay, yep. Then 1, 2, 3, 8, 9. Excellent. So that detail is the button. That's good. So we can now just continue everything else. Yeah, again, I could reuse this, but it's only used twice. You know, just gets a bit annoying defining a new function everywhere, you know. So it's just going to say 4 words, I think. Yep. XC type. Okay, so remember, I've got to see this vert thing. We've got to delete that, and we've got to provide the actual input device. So we need to find the input device. Now it is this thing here. We are probably going to use it quite a few times. So we probably want like an internal function. You know, the joy of declaring functions. So we want to say like find input device, find device node with device node or dev node. So you just pass in the dev node string and it will find it. So you just want the OS device input device ID. So we'll implement that. Well, we've already implemented it, right? What we're doing, we're trying to find the OS, raw motion. Excellent. So I've already got it here. So let's do relative position. Right, so we should be able to use pass in the device node. When all of this comes with us, bear in mind we should have really copied that before we did all that change. Yep. Now we can go to here, drop that in there, go back, delete the rest. And that should be... Now, if you don't find anything, it's kind of problematic. So we should probably just say, okay, you know, just silently fail. Right, that's okay. It's okay to silently fail there. Okay, so nice. Here we're just going to return the null version. Wait a minute. Core ID raw. Wait, null. Yeah. OS input device ID. Cool. So this looks specifically for the mouse one though. Crap. Hmm. Hey there, Liv. You said you have so many questions. Yeah. Yeah. Just ask. Well, I don't know. If you don't know what this project is and you're interested in finding out, we have YouTube videos up here. You can watch some of the devlogs. Start at 0, work your way up. Maybe that answers some of your questions. We also have past streams as well available on the VOD channel. I don't know why I just didn't do the thing. But yeah. Hopefully that answers some of your questions. Yeah, of course you can stay here, Liv. Alright, that just crashed. So the problem is we've got like 5 or so different device node things. Now the way I'm thinking about this is going to work is this sort of like, you know, maybe I shouldn't have made this a function. Because it probably just deserves to be, I don't know why I made this a function. Functions are evil. Never make functions. Pure evil. Anyway. That was a waste of 2 minutes. Okay, where was we? Raw motion. So raw motion it basically did an iterator to find, you know, we need all this. So basically we want to only do any of this providing that the device node property actually exists, right? When the device node property exists, then we can possibly create some events. And then what we want to do is actually find the device. Okay. So we also only want to do this providing that it is a mouse. So we are just going to then break. I think it sets it to null when you reach the end. Is that right? Crap. Source core C. It's a next on the object pool. What does it do when it reaches the end? Yeah, sets it back to null again. Excellent. So really all we're saying is like, okay, only if this is not null, then do any of this. And then we can put the input device in there, and we should have per input device events. For the mouse moved, mouse wheel moved, and button changed. Alright, that needs to go there. Good. Okay. Wait a minute, that didn't do a break. That's still firing the mouse moved event. We're not doing that. Good. Cool. Yeah, you know, I might actually just do this, right? Uh, make the other one have a similar pattern. Hey, Jamega, how you doing? What's my take on Bitcoin? I don't know. It uses a lot of power. I don't know if it really solves the problem it hopes to solve. You know, it's not really been tested. People say it's been tested, but I don't know. It's still got to be around for like 100 years and find all of its problems because things all have big problems. Um, yeah, I don't know enough. Um, you got to try Java. You've never tried Java. Chain terminal programs through pipes. Oh yeah. You know what, guys? We really. I know this sounds really crazy, but the blockchain, right, is just a data structure. But I don't know if it's worth doing this. It'll be a bit of fun. It'll be it'll be insane. Like in the back of my mind, while we do this project, and we probably won't do it. But if there is a moment where it makes somewhat sense and it doesn't destroy the code base too much, for a bit of fun, we could do a blockchain. So all a blockchain is it's a block with like a bunch of like entries in there that hold some data. In Bitcoin, it's a list of transactions, right? But it could be anything. It could be saved. It could be anything, right? That you could put in here, and basically this all gets hashed, right, into a single like this all gets hashed up into like a single value, right? A single hash value, and then it links to the next block. And then again, you fill it up with entries. And then what persists is a chain of all these entries. It just persists, right? It just keeps going. And the idea is if you change anything in this, it will invalidate the whole hash because you hash this one, or the hash is comprised of this one, and then the next one, and then the next one, and so on. You're hashing these into the same into a hash function again, and just or you're combining the hashes rather. So if you change any piece of data, it invalidates it, right? So for a bit of fun, and to say we use blockchain technology in this game, just for the lols, we should try and incorporate that. Just that bit of tech in there, you know. Because I'm sure it'd be a bit fun. But I'm sure, again, like OOP, it probably doesn't solve any problem really well, you know. We'll see. It's all for a bit of a creative challenge, you know. Can we do it? More than anything. Yeah, you cure cancer, perhaps. How? Yeah, it can invalidate every cell, right? And if it changes, it will just invalidate the whole hash. Done. That yeah, that will not work. um, there is hope. Oh, the hope is that the regulators will collapse. I'd assume. Be real World War III at that point. Hmm. Oh, it'll fall apart when it hits the regulatory stage. Right. Hmm. Oh, the bot doesn't do anything when you type Java. Oh yeah. What version of it do you mean? Oh no. I don't know. Just OOP in general. Bum bum ba-dum bum ba-dum bum. Right, does it work? So we're looking at mouse clicks. Oh yeah. So notice, oh, it's really hard to see, but because the mouse move just tracks everywhere, and it will do, right? Because it's the raw mouse moves. So we might have to comment this one out. Should we comment out the mouse moves? I don't know. Even when it's like minimized, we should think about that. But anyway, so when we click here, we've got a virtual mouse button clicked, and we've also got the regular mouse button clicked as well. But yeah, they're both showing up on a device. But now if I plug another device in, right, this is where the fun begins. I only have so many ports on my PC. Okay, so I've got two mice plugged in. I've got this Corsair, you know, Elite Rainbow Vomit Edition. So when it eventually picks up, there you go. So if I click, so if I move it, it's got a number of like, I guess, because we set a high bit because of the counter, but it's 7/8 basically, right? So, and then now we move this mouse, 77, 78, 77. So different devices. Then if I click, 77 is clicking and 78 is clicking. There we go. So that's pretty cool. So finally, yes. So I'll leave that one plugged in. But yeah, notice when I detach it actually, input device disconnected, Corsair Gaming Saber RGB Rainbow Vomit Edition. There we go. Isn't that amazing? Oh, there we go. Okay. Cool. So that's the mouse, right? We didn't really test everything. Scroll wheel, yep. Middle click, yep. Left right click, yep. It's good enough. Good enough. What else are we doing next? So I want to do the keyboard next, isn't it? And then we're doing gamepad. Oh yeah. So the keyboard is just going to be like super quick. So we'll copy all of this basically. We'll repeat it for the keyboard. Really, the mouse is kind of. Oh no. Really, the more popular one is the mouse. That should really go first, but oh well. Doesn't matter. Key press. Key release. Cool. So we'll do all this stuff again, get the device node property. Yeah, because we only know if it's a raw event. Yeah. So we'll have to do it every time. It doesn't matter. Maybe there's a way to simplify this code, but I also don't really care. So this time I'm looking for a keyboard functionality. Right, iterate all the input devices given the device. Oh, sorry, and find the device node for keyboard. Yep. Now we want to try and find where the other key press event code is, right? So here it is. Again, I could share this code, but you know, function and code sharing is evil, so we don't do it. So we're going to go over all of this, highlight all of the stuff we just entered in, and let's make our adjustments. So I don't think there's too much to keep an eye out on. Keyboard, mouse, we did that, it's all good. So it's not virtual key anymore. It's specific to a keyboard, so I've got to plug two keyboards in and give it a go. So we're going to do input device ID goes in, and input device ID. Would you look at that? So let's give that a go. I want to obviously plug it all in. Yeah, get it all working first. Yeah. Good. Well, if you have a struct with data and then the functions whose main purpose is to operate on the struct or contracts, you just made OP. No, that's not right. That's not OOP. Like, OOP is encapsulation, inheritance, and wait a minute. Yeah, there's like what you're describing is not object-oriented programming. Like that's what people want to. Hit the mic. That's what people want to think it is. But it's given it too much. It's given it too much credit. You know, like because if it was that, that's fine. But it isn't. Um, you don't need full Java OOP. OOP is grouping data with functionality. Sure, that's a part of it, but there's still other things about it, right? But yeah, part of the problem with OOP is like there's not really one definition of it. There's many definitions. You know, there's like the small talk thing where it's like message passing. Uh, you know, and there's a whole bunch of things. Yeah. So interfaces is a part of OOP. Yeah. That's a good. That's probably the one of the best sides of OOP is interfaces, right? Because you're not putting a constraint on the data, how the data should look, and it's mainly used as a way to sort of share code in a way. But it's good for like generics. You know, the constraints on generics. I do like that about traits. Right, I'm going to switch on the light. It's getting dark, and then we'll plug in multi keyboards, test that all out, and then we'll do some gamepad. Oh yeah. Ugh. The OOP has a lot of different definitions. It all depends a lot on how you look at it. Yeah, but yeah, I wouldn't give like giving OOP the credit that it's just mixing data and sorry, whatever you described it. Yeah, that's giving it like telling people that is just open up the door for people to just believe in everything else that OOP is. Like it's not a good way of yeah, it's not a good thing to do, I don't think. Yeah, I think OOP is a bad name for describing what you're saying, Joe Omega, because it's giving it too much credit into being something good because it generally isn't, right? Like if it was that, if the people who came out and was like OOP is amazing and in the 90s and everything, like when I was like, eating crayons or whatever, back in those days, like they were saying it's something completely different than that. This is how people, yeah, yeah, uh, Yeah. I didn't know. I didn't. Yeah, I think rather than oop, I was just doing more poop at that time, you know, when I was eating those crayons, you know. Um, yeah. Mm. But yeah, it really got. Yeah, I don't know. There's many definitions of it, but yeah. Right, multi keyboard. Plug this bugger in. So I've got to be really careful. Yeah. Because my keyboard takes two things, right? It's super versatile, right? You need two ports. Um, so the problem is I got one in one place and one in another place. You know, I could go around the back of my piece. Nah, it's even more problem. And if I nudge one of my cables, my sound gets disconnected for a second and OBS throws a fit. So yeah, one of those. Yeah. Right, so it's plugged in, and the sound is still good. Uh, yeah, like if OOP was what you're saying, Jamega, like I don't think anyone will have like anyone who has problems with OOP will be having problems. You know, because most people do. You know, they do what you say, right? And it's not bad, but the program is divided into small parts called functions, small parts called objects. Top-down approach is a bottom-up approach. Okay. In procedurals, there's no access specifier in procedure. Is public, private. Well, that's still a lie. As I'm saying, you can do it through, you know, systems and, you know, including different files. You know, um, adding new data and functions is not easy. What? Okay. Less secure, more secure. What? Yeah, this is garbage. Yeah, geeks for geeks. Mm, mm, yeah. The function is more important than the data. This is really bad. Oh my days, the data is more important about the function. Guys, did you know about that? Apparently, object-oriented programming, right? Data is more important than the function. It's based on the unreal world. Object-oriented program based on the real world. Is designing procedural program, design medium-sized programs. Object-oriented programming, large and complex. So, okay, maybe it becomes large and complex because of OOP, not just because, right? You know, uses the concept of procedural programming uses concept of procedural abstraction, concepts of data abstraction. Oh yeah, yeah, that really did get worse as it went. That was an insane read. I'm gonna keep that one. I might share that one around. That is Wait, who wrote that? And difficulty, easy to read because I'm just going to tell you how to think. I give them that. It's in a table, right? As a Gen Z, right? Paragraphs are too much. Tables, bullet points, I'm all on that. Or a video, you know, like a video. I'm a borderline Gen Z and millennial. Oh no. What have we done? What do we crash now? I crashed because I got multiple keyboards or because I have... Ah, it's in the new code. Oh yeah. So the problem... Ooh. Right, I copied and pasted this in and I was like, oh, let's just plug it all in and go. Obviously, we didn't finish it. So... Right, give me a second. So, this state is the raw keyboard. The state is a key or button mask. The key codes. And we chuck it through there. Alright, what's the next key? Is that key sim? Oh no. Right, so maybe we can't do this key lookup thing. Because that wants the event, isn't it? But we could fill it in manually. It's not a problem. We're just going to ignore key input. Wait a minute. You might want proper key input. Okay, lookup string. Do we have lookup string? No. Right. So we're going to have to fill the structure in with the raw necessities. And then do a lookup string on it. Not a big problem, I don't think. So the fun thing is we actually have the keyboard state anyway. So control mask. Right, and what we need is a shift mask. That's all we need to chuck on there. There is a the mod mask as well, like the alt. So we need to know what is alt basically, or alt gr, right alt. So we'll have to put those on, but we can do it. So we get this X key event, drop it in there, we'll fill it all in. Wait a minute, I'm in the wrong one. This one. So basically we'll zero the structure. And we want to fill in a lot of this stuff. So we want to say type sorry, xkey.type. We'll just say it's equal to key press. Doesn't matter, I don't think, so much. So I think the only ones it's really going to look at is key state. So we'll say xkey state. So the key state, so we're going to make this thing. So we're going to OR. So because we've got a current device, we should be able to say input device. There's a discussion tab. Yeah, I guess it allows you to secure on the secure thing, modify less data, but again, you can still do encapsulation in procedural style, right? Um, okay, so we got to there's like a key mod state. Keyboard key mod is pressed bit set. So there's a OS key mod. Here we go. So I don't know what is mod 0, mod this and mod that, but I know what control is. So if this one is set, it's basically... Oh no, we don't want control, sorry, I meant shift. We don't want control, we just want shift. So that'd be shift mask. Right, just they're using all the good names, clearly. But then they're using like mod 0, mod 1, so we need to figure all that out. So what is Linux mod 1? Yeah, what are mods? Simple answer, download. Here we go. So left alt. No, I think that's wrong. It's got multi-binds. Mod 1 is alt. Good, thank you. I guess it depends, right? You can bind whatever. Mod 4 is Windows key. Oh yeah, Ransel, keep it coming. So what you're saying is the left alt is mod 0, mod 1 mask. And also what you're saying is the left, did I call it meta key? Yeah, 4. Alright. So I guess that one doesn't actually matter, because all we really care about is the right alt, I think. So right alt, so I think there's that command we can run. Where's the right alt? Yeah, I only called it meta because I copied it from the thing, but yeah. Where's the right alt? But yeah, I don't know what I want to call it. Call it super, call it Windows or whatever. Was it a mod what? Because alt GR is different. So I guess the way we can test it is simply just print out the mask of... So obviously we if zero this out. And we'll just print out the state and just see what we get. So and if ta-da. So we want to go where we do this control mask thing up here, print it out. So we're just gonna damn it. Shoot. Cool. Let's give it a run. The right alt did nothing with the state, which is interesting. Oh, it took away. Alt-GR took away 8-0. Oh no, it didn't take it away. Okay. I know which one it is. It's we just gotta go and find it. Alright, we got it now. So right. 8 is the fourth bit on in the nibble, right? So if the hex is so if it's 8-0, it's the second nibble, so it's the highest bit in the byte. So it's mod 5. Right. Ta-da! Mod 5. So that'll be all we need, I think. Cool. So the next one is the key code, and that should hopefully just be detail. Which comes from DE device event detail. So a raw event. I don't think we need anything else. We can delete all that. And then we should be able to use this X lookup string thing on X key. A nice little local. Then our key code, our evdev key code should be detail take 8, but it might be wrong. Because the X11 key code is just 8 more than the evdev one. So we'll give that a go. And again, this is a little bit wrong here. We just got to copy this one. So hopefully that works out good. We'll be able to see. It shouldn't crash anymore. And I'm hoping that function only uses. Ah, it crashed. 557. Oh, it crashed here. Crap. It's because we didn't find anything. That's why. So we need this if statement here. Shift it all over by 1, please. Cool. If we actually find a device and have a valid pointer, these QMKs changed the right mod keys to the left because so much software uses the right mods. Huh. Yeah, Alt-GR. No, it has a right, yeah. Right Alt is Alt-GR. Yeah. I didn't realize so much software ignores the right mods. That's weird. Okay, so what we're planning on doing? So we've got multiple keyboards now, so it should work. So I've got my Mac keyboard in front of me. I've also got my Corsair keyboard. I wish I could show you guys more, but so I'm going to press a key on my Mac keyboard. We don't see any event show up. So this is an epic fail. Let's close and see why. Why don't we see anything? That is the question. So we need to do a print yay again. We need to go to yay. There's no yays. So that's not good. So let's do more. So clearly, okay, so do we land in here? Do we search? Okay, we've got some yays, right? So just doing some searching over 2 things that are plugged in. 2 things. Yeah, 2 keyboards. Good. So why oh why? Like, what is this? I've seen a whack keyboard layout while I was briefly working in Germany. Always carry my own keyboard at that, in that place. Yeah. Ooh, what's the German keyboard layout? Right, so yay 19, okay. So it's got something sensible in there. So let's see if the device node that it's picking up is something that we're looking for. 16. Oh, so the 16 one is empty for some, it's an empty string for some reason. But the 19 is not. Why the hell? Is it an empty string? And you've managed to set... Oh, with mouse. But it... Oh, because one of mine pretends to have a mouse or something like that. Yeah, I got it. I don't know why. I don't know why. Right now it fails. Right, so the XIM lookup thing fails a bit. We need to look into that. So maybe we didn't fill in all the things that we needed to fill in. No biggie. So yeah, we're doing something correct now. So things are coming in, but this is kind of failing still. So I think a bit of a problem is some of this stuff. Yeah. So we need to basically steal over the so we'll copy this with us again. We'll go into the and put it down here. And also go into the raw event. And I'm going to grab all this one and just copy over the stuff that we got from the raw event. Great. And we'll copy over the stuff from there to the fields that match. So obviously not type because type is different. Wait, where's the detail? Did we undo something? Did I undo something? I don't know. Screw it. Maybe I overwrote it. X key code equal device event detail. Right, so what else are we missing? There's this thing called cereal, right? You know, a very weird word, cereal, because it sounds like breakfast cereal, but it's not. English. D cereal. Right, send event as well. Let's get that in there. Display connection. Get that in there. That's probably one of the ones that's causing it to crash. There's the thing called window now. That's relative to. Maybe we don't need that. You know what, let's put it in. So it'd be OS backend. Wait a minute. OS window backend X11. Fantastic. Oh, German keyboard. Let's take a look. Oh, Quartiz. No, sorry, Quartiz. Switch the Y and the Z. Right. So you've taken up an extra couple of the keys as well, right? Yeah, for these guys and that one. So I've got the semicolon. These are down here. A couple of Alt-GR guys. Right. Look at that. Programming. That thing's, that'll give you a, ugh. Can I, the wrist pain that'll give you, putting the thumb on there, right? And then pressing those. The reach you got to do to put the thumb here, that'll give me a wrist pain. Anyway. Maybe you're best to split your thumb and use your other hand to do these guys. But yeah. Or just use the QWERTY keyboard layout. Or the Colmac, you know. Oh, this is your one. Oh, the Swedish one. Yeah, yeah. Yeah, basically the same. Yeah. And then A30. Oh my days, what is this? Oh. I'm sorry, but this is probably one of the worst ones. At least you can do BitTorrent right, you know. It's one they use for French. Oh, of course. Right. Yeah, I remember now. Hmm. Yeah. But you guys should all switch over to this one. It's a keyboard layout designed for computers and not typewriters, you know. So come and join the fun. Keeps your standard ZX CVs, right? And then all of your vowels and all your important stuff is on the home row. And then all the rest of it is in different places, and it's a smooth ride. So lovely. I can like spell my whole name on the oh no, I can't. But yeah. Colmac is the way. It is the future. Look at this heat map. It's probably not legit, but there you go. Colmac. There's your QWERTYs. There's your Dvorak. See, Dvorak was designed for the typewriter still, but Colmac, you see, designed for the computer. Continues to be staggered. Yeah, but it's not column. Sorry, but that's to do with the keyboard itself, not the keyboard layout, right? The virtual key codes. Well, I just remapped my Vim, and also Vim kind of sucks, right? Default Vim sucks. Here's why. Default Vim is like, you know what? Your fingers rest, obviously because it was designed before, you know, in the before times. Your fingers by default, pinky, in whatever that one is called, sub pinky finger, whatever it's called, I don't know, second pinky. I think, sorry, the ring finger maybe, that's it. Pinky, ring finger, middle finger, your index, or your prime finger, I don't know what, anyway, the main finger. They rest here. But then Vim is like, you know what? Whenever you're in navigation mode, you need to shift them to the left by one and rest them here. So by default anyway, it's good to just shift it to the right and remap it to avoid that anyway. Because you're just constantly shifting from left and right, and it's just silly. What else? Yeah, so like the default Vim bindings are all a bit weird anyway. They're just good to remap. So if you change keyboard layout, just remap. You end up remapping Vim and finding a new a better layout, basically. Thumb, index, middle, ring finger, pinky. Thumb, index, middle, ring, pinky. Got it. Where do you guys buy keyboards? I don't buy keyboards too much. But yeah, what's everyone else's keyboards that they like using? So did we fill in everything else that we needed? Window, root. The root window, that's easy to do. Wait, that's... Yeah, it's just to this. Default root. That'll do it. So root. Sub window, I don't know what that is. Time, we've got a bit of time in there. DE time. XY, I think we can leave all of that alone. Hopefully that'll just work now. So delete all that. And hopefully that should be the multi-keyboard stuff done. Oh yeah, that worked. Sweet. So we're getting text input T. Oh yeah, right. Let's give us a go. So we can see it all. So I press the T. Oh, there's so much stuff printed out. So we've got virtual text input, and then we've got a text input. It's just, this is annoying. I want to move my mouse without it telling me to move my mouse. All right, now we can see. So press the T key. We've got this virtual key. We've got the one for this specific keyboard, and as you can tell with the virtual, it's got an F key that I pressed, but my Comet keyboard, it was a T. So F and T, that still works fine. Great. If I hold it down, we'll get a bunch of repeats, but not for the not for the raw keyboard at all. The raw key buttons and stuff. Right, that should be fine. So just press then release. There's no repeats that happen. Okay. Yeah, maybe we should. We'll think about that in, as things go. The keyboard's my Moonlander directly via. Cool. It was raining when you found it. The Park keyboard, excellent. Yeah, I've got a Corsair keyboard which I use, which I'm taking a break from right now. I'm going back to the Mac keyboard, but yeah, I'll go back to the mechanical keyboard a bit. I was just letting my fingers heal up and stuff like that. Too much typing. But yeah, so if I press the A key on this keyboard, then press the A key on the other keyboard, what you'll see is we've got different input device IDs, right? This is 78, 76. So that's cool. And that's 77. So yeah, we did it. Complete it. No, I just like the Mac keyboard because the key travel is tiny. So it's really, yeah, it's really decent if you have like joint issues, basically. Yeah, I've been doing like lots of stretching lately and it's been helping out. So I'm hoping to be able to go back to my Corsair keyboard. So that'd be cool. But yeah, it's a 2007 Mac keyboard, so it's not like the new ones where they're like little clicky keys. It's more of like a membrane thing, I think. But yeah, doesn't sound as nice as the mechanical, obviously. Oh, solder about together again. Fantastic. Right, any little things we need to fix before we want to dive into the gamepad stuff? So the fact that this moves, oh yeah, we want to, yeah, I think that's all fine. I think that's all fine. Right, so we're getting super close to finishing now. We just got one last kind of like subsection to do, and that is obviously the gamepad. All right. So let's give a bit of a play. So we've got the input device working and everything, but now we need to actually hook everything up. So we've got this new lovely program called evtest. At least not the Apple mouse with the genius design of being the charging port on the bottom. Sounds incredible. Incredible design. And I love how you use the word genius, because that's the word they use all the time. Oof, just unplugged that, was good. Yeah, actually, I quickly need to get another drink. But yeah, I'll be right back, and then we'll give this guy a go. And yeah, so I'll be back in just a sec. Oh no, I destroyed. When did my camera freeze? Just now, which is good. Okay, we're back. Yeah, I just knocked the USB, so right, I'll be back in 2. Enjoy the tunes. Right, welcome back, everybody. So let's just wire this in. There's the cable. I need more USBs, you know. I should get another hub, you know. Right, so I'm gonna plug in the controller. So the beauty of this is, right, there's a nice little program called evtest, right? So there's this thing in Linux called event device. It's called event device. It's, you know, for short it's called evdev. And so we search for like or maybe like a joystick. So we did this at the start of the stream, right? We find our joystick one, which is on event 19. So you basically read this with the read system called like a file. So we should be able to say evtest. So now it's saying that it's got rumble on there as well. I think, I don't know what it's saying there. We should throw that into less so we can see it a bit better. Right, so saying input driver supported events. It's got this evsyn ev key. So it's got all these. These are the face buttons, a couple of triggers, start select, mode, thumb left, right. It's also got event type ABS. Now ABS is, from what I understand, is the accelerometer. Right, so you've got event type 0, which is this one. Seems like it's got nothing. Oh, so I'm going in specifically into this one here. But then it's telling me that there's these other two. Right, it's interesting. So this also supports this one, which is probably like accelerometer and gyro. Telling me their ranges. We've got to figure out how to get these ranges, you see, when we do that. So that's something to figure out. There's also like rumble and I don't know things, right? But anyway, we've plugged into event type 1, I think. So anyway, yeah. So if I move around, there's nothing. Right, that's just me hitting the analog stick. I want to be careful hitting those analogs because if I do, there's no, they've got to be on absolute 0 basically. If not, they're just gonna go crazy. So I press the face buttons. You see, we've got south, west, east, north, up, down, left. That wasn't good. Anyway, so it did something there clearly. Gotta be careful. This analog stick is doing something all the time. It's being annoying. But yeah, so we're gonna use this to. So wait. I got this PlayStation 4 controller. So if I plug this one in and test this out, has it got the same buttons? But we might be better off just looking at SDL and see if they do a button map. I think they do a button map, regardless. And the PS4 controllers suck. Like these things always get sticky. You do nothing, and they just get a layer of stick on it, and I hate it so much. They never fixed it. PS5 they fixed. They're a decent controller, but they just get sticky. You gotta wipe them all the time. Not a fan. There's so many USB-Cs. I don't know why. Looking for a micro USB now. Wait a minute, I've got a charger cable somewhere. Right, let's go find my charger cable. I'll be back. Right, so I'm back. Let's try this one out. I don't know what we can capture. Well, maybe we can have them both running at the same time. Hmm. Oh, I did it again. So I decided to log all features and properties for Vulkan device in my log. Learned two main things from it. One, it's a ton of data. Two, my logger is kind of slow. It takes 20 microseconds to log. Probably. So, yeah, you can do it quite easy to log, right? Yeah, you do it per device, don't you? Yeah. Nice. That's not that much data. Could be more data. Micro milliseconds? Wow. Yeah, you saw that log out. But yeah. Is that in debug builds though? Yeah, this is good. You want to do this per device, right? That you pick up on. And also, do you? Oh yeah, you will use some extensions, isn't it? This is cool. Nice. Yeah, rolling out the big guns there, the 4090. Right, let's plug in this PS4 controller. The one with sticky analog sticks. So bad. Cable. Okay. Oh, I did it again. I nudged the keyboard. I nudged the thing. Uh, okay, we're still here. So let's get some joysticks. Um, 24. So 24 and 19. The analog sticks are going crazy. But we maybe just want to pass into less, right? And just look at the top. Yeah, I feel like they also have accelerometer gyro apparently. Is this right? Yeah, this is the PS4 controller. I'm pressing buttons on it. But yeah, I think they map to the same thing. I just got a feeling. Oh, so you can move the mouse still with the touchpad. So the analog sticks are going crazy. I'm trying to center them, but it's not doing anything. But yeah, right. Ooh, what is that? So I'm gonna press R1 a load of times. R1 only. So you get this this guy. Right. So, you know, Sony must do the exact same. Yeah. Yeah, it doesn't, if you, depends on the device. Okay, fair enough. It's just the value differs so much, you see. But yeah. It seems slower in release. Oh my days. Um, hmm. What do we want to do? Yeah, so I think I want to just quickly look through the SDL code maybe and see if they do. No, they must do button remaps. They got it built in. So my question is like, is evdev button mapping, I guess. I have a feeling that they probably might not all be the same because it's for like a joystick, right? It's not really for like a game pad. So you gave me post a link. Sure, I guess. I'm not sure if I'll download it or anything, but I'll have a look at it. Um, um, awesome, no download, sweet. Now I want to unplug this PS4 controller because the cable's getting annoying. Alright, we're still going. Okay, that's good. So basically, the thing I was really interested by is when we do this. A minute. When we plug it in, it tells you what it supports. So what I want to do is look at this EV. I want to look at the source code of EV test. And I want to just see how it works. Right? So the thing that it says is like supported events. And then it goes over all of this and does a test bit to figure out what it supports, right? Okay, that's interesting. So something. Okay. So then it also goes over these different event types. Event type. Logging to the console, unnecessary flushes, right. What is this? Does it run in dark mode? I died. So it's an endless runner. Do you get any abilities or anything? There's 3 lanes. Okay, just an endless runner. Cool. Right, see you later, Jamaica. Have a good night. How did you make this? What tools did you use? And you randomly spawn boxes and trees, and you have a track that goes down the middle. This ghost thing. Good up, fair play. I kind of went into the box there. It was interesting. But yeah, fair play. Wait. You press R to reload. Wait, you can shoot? Oh, R to reload the level. Right. Oh, but R's in a different place on the keyboard, so it's there. Let's see. Nice. Good stuff. So What is this doing? You go and get the file descriptor. What file descriptor is it giving? Is this on the main function? Do capture from device. Is it the one you pass in from the main function? If mode capture defaults to capture. So you just take in the device, right? That you get passed in. The device should be equal to arg. Yeah, good. Okay. So they're using this like IOCTL thing, where it's called. Let's go to that definition. I'm not sure if I like this thing. It's kind of useful. Right. So they use this IOCTL on the event file descriptor. So you've opened up the file. So we can open up the event file descriptor and we can go. So you can get the version of the input driver. You can get the device ID and all of that, but we've already got that through different means anyway, using evdev, right? And then it's going over support events. And it checks to see if a bit is set. Wait, event type. But then, if I do a different... Like, I can't get these guys. Oh, X, Y, Z. Oh, these are the analog sticks. Oh, yeah, those are just the analog sticks. Yeah, right analog, left analog. Okay, gotcha. So what would be interesting is like, if we could write like a... Do we need to write a generic thing where we sort of go over the supported stuff? Or is it better off... is it best to go get these support properties? Maybe. And then mapping that into something. Is evdev joystick standardized or something like that? Game developer, 3D tile for Linux. The older JoyDev and the new evdev system. Each of these systems has set parameters, joystick calibration. Right, SDL controller has a build that maps the evdev buttons to their 360 analog. In the case SDL isn't... Sorry, in case the controller isn't known by SDL, you can use environment variable to set a custom thing. Right. So I believe there might be an issue then with the you have to do a remap. Because they can say it's whatever whatever they want, basically. So in that case, you might have to do a more general API, or the more general API where you figure out which ones to read from it, right? But I don't know if I want to use this. Well, maybe I'll open up the file descriptor for it right away, I think. Okay. Something I learned about as well is there's the accelerometer. And that's event 20, but it doesn't allow me to read the accelerometer without sudo, I don't think. I need sudo apparently. Can I do like a cat on that? Which is not good. Like, if I can't read the accelerometer without pseudo? Like, so maybe we should see how SDL does that, because that just seems weird, unless they're using the old JS joystick API, you know? I don't know. Can you cat that thing, JS1? So I move it around, and it's going to do stuff. So the old joystick API work. So maybe the accelerometer stuff comes through maybe that comes through X. Gesture pinch. On it. There is like a motion event. But motion probably means mouse, right? Because we've plugged mouse in with motion already. I don't know how else it would be plugged in. So shall we print out here and just see if there's anything that shows up? So if I run the game, nothing. Nothing in raw motion land shows up at all. So obviously it's not that because there's obviously mouse. What about any of this touchpad stuff? Does any of that work? This all shows up. But it's not showing up as a... Oh, because it's looking for mouse instead of touchpad. See, so if it's equal to touchpad, you want to, or mouse, you want to look for slightly different API. I guess the buttons might work the same as well. So what you're kind of looking for is like, if it's equal to mouse. And this. If it has touchpad. So we'll try that. Give that a go. So I'm even using the trackpad, not the touchpad here. Oh, that crashed. So it's crashing here because it's doing a get checked, but the feature was either or, you see. Let's flip those on. Um, right, let's give that a go. Let's try again. Now his mouse is being moved. We can click. I don't know if there's a left and right click or if there's only two button things. Or any scrolling. Doesn't feel like there is. But at least that gets plugged in. But yeah, this other stuff, like I don't know why I can't read the accelerometer. Should we look into the SDL source code and see what they do? Just gotta remember where that could be. In the joystick system, right? So source joystick Linux. Wait a minute, because they've got udev and evdev. So that is in core evdev. Core Linux evdev. See. So I don't know if they have mappings. Right, the word map doesn't show up. So they've got like device added and removed, I guess. But this is for if you run it without udev or something. ev underscore. Right. So this is mouse processing, maybe. It's in a read. We will be doing this stuff in a bit. But if they read a key. Oh, so there's a type. So we saw that in the. Wait a minute, 19, wasn't it? Right, it's a type. Ah, so there's a type key, then it could be any one of these buttons. Right, and then there's 3, which is ABS, which means probably. Right, okay. So you get a type anyway, and then. See, this is all about keyboard though. Probably keyboard. Yes, this is not gamepad. Kinda. So should we grep for EV key or something? So it also shows up in sys joystick. So that's probably a good place to look at. So joystick, Linux. Right. So what you're looking for here, guest class, configure joystick, see if the device uses unified API. Right, get the number of button axes and thingy-majigs. Good name. So you go over all of these buttons. What is that? Right, so it, like that EV testing, it uses that IO CTL thing to get the mapping. Sorry, to get the supported keys. To see whether the key is enabled, right? And then I guess there's some mapping that goes on. Get gamepad map. Do. That's button. Oh. So I'm not sure what they do with this map. So mem set it to all on, I guess. All the bits on, some says invalid. Poll all of the buttons. Yeah, see, so when they poll, they do a similar thing, and they send a joystick button and its value to this. This is probably gonna do something. So probably run its through. Oh, key map code. Huh. So what is this? Get joystick mapping. Okay. Based on the Android gamepad thing, fair point. So basically they get gamepad mapping. A target, A, B, west, Y. So I guess this is some sort of like default mapping that they build up, right? Linux gamepad specification uses RX and RY axes. And if it's for Microsoft, they do some special things, I guess, to get here. Okay, that's interesting. So if it, so we're trying to think like, do they joystick get mapping? So is this a fallback, right? If they don't have a mapping, like they just default to that, So let's look for that. Grep. And then we'll look for the joystick. Get gamepad mapping. So and then we need to look for how they do the accelerometer, right? Do they open up that event file? Because we can't open it because it needs sudo. So how do they solve that problem? So they end up calling like some function pointer somewhere. Wherever that is, right? Clearly I can't see it anywhere. Where are they calling this? Joystick driver. Where's that definition? Do. Oh, right, slightly wrong file. Oh man. Right, sys joystick. SDL sys joystick h. Okay. So we've got a bunch of function pointers. And the name is on the bottom, get gamepad mapping. So I think this function is only called once. Right, so it's test gamepad, that's in a test file. So joystick C. Take a look at that one. What is that? So mapping. So private joystick get auto mapping. So it gets the auto mapping. So again, it feels more like it's only done as a default. Get auto mapping, that's in the gamepad. So it's still in joystick. Right. Get private mapping. So if it doesn't have a mapping, they do that default one. Fair enough. Yeah, that's fair play. So yeah, I think we'll have a default mapping anyway, but in like, and we'll do the standard thing for all of our controllers. And I guess in future, when we actually need to make this thing work on more controllers, we can add some form of keyboard mapping thing. Sorry, gamepad map. All good, all good. So now we've got to figure out how do we get this accelerometer thing to work. Because I don't know how they're doing it really. So we're going to the joystick internals for Linux. Let's have a look for accelerometer. Yeah, so they're setting it up right. It'd be good to figure out that scale thing, but do they open up the? Do they open up the event? Oh, they read the value this way. Right, so you have to use IOCTL, FD sensor. So they're using the file descriptor, and you have to use IOCTL, and you read it out that way. Great. Okay. They have to be read out differently. You can't read it for some reason. What is this way? Handle input events. Report sensor. So some sensors get read through the read to score, right? Whereas sensors are only available through new unified event API. What is this new unified event API? Oh, and this is setting it up. Wait a minute. Open, that's fine. Poll all sensors, right? So it's saying if it has gyro, it has accelerometer, do it this way. It's not saying anything else, and that... Right, so if hardware fresh, false. If report sensor, report sensor. Yeah, but I feel like they opened up... I think the biggest problem is being able to open the file, not read from it. Like actually open it. So perhaps they're using a different... We should look at their evdev and see what they get. Yeah, evdev. So where's the accelerometer? So it's on the input, they get the accelerometer. Path equals device node, right? So they're passing in the event node for it. Sorry, the event thing for it. And they call the callback, which probably just sets it up in joystick, right? I don't know how they're going around the system thing. I'm not sure what you're saying. Sorry, friend. But yeah, they use an open joystick. No. Hmm. Sensor enable. Wait, was we just looking for the joystick or the gamepad? It was the gamepad because it sensors. But yeah, so they had that the FD sensor. Okay. I've used Rust before. It's fine. I used it for like 4 years and I decided it's not the thing. Yeah. You know, why are people struggling with C when you got PHP, you know? Because PHP was built to replace C, you know? I don't know why people use C. Wait a minute, there's an open syscall somewhere. Is it in joystick? Wait, this is the high level. In Linux. Excellent. Alright, isn't it? I open the stream and the first thing I see is Russian Rus propaganda. Oh yeah. Zig, yeah. Amazing. Right, so maybe a device with path. This is it. And hey there. Hey there, welcome to stream with Falago. Welcome. So it can fail and then it returns. See, the thing is, I think it would fail because we haven't got the permissions, and I don't know how they're doing the accelerometer if they're calling open. So I guess we can write the code and try it out. But I'm just a bit confused. Prepare joystick data, sensor. Alright, what is this? Open read write first, so we can do rumble. Right, item sensor. If open sensor fail, continue with buttons and axis only. So they actually open it, right? FD sensor, you see. Non-blocking, oh yeah. So it's interesting, they managed to open, if they actually managed to open it, like, because if I try and do a cat on the accelerometer, it just doesn't work. I have to use sudo. So I don't know. Set joystick enable, they run it through here and it probably works. Obviously, I could compile this code and test it out, but we do have a test thing. We could jam into the test code, do an F0, and what was it, event 19, wasn't it? Event 20. Does it open? Let's run a little bit of Clang on it. Run a test. Failed to initialize evdev. Sure. So we tried 20, which is, but we did 19. That'll work, right? 19 is like the buttons and stuff like that, like the analog sticks. That'll work. Does not look like a mouse, fair enough. But yeah, it was reading it like a mouse for some reason. Oh, you can use libevdev. Oh, past me has some answers. So rather than using that IOCTL thing, we can use libevdev, which might use that IOCTL thing under the hood. I don't know. But let's use this anyway. Maybe. Because maybe you can use it to get all the keys. Oh, get maximum. Oh, this is a good library. Get the minimax ABS. Yep. We want to get a bunch of other things as well. Like, what are the available keys? Maybe. Yeah, so maybe we'll look into this libevdev thing. But yeah, do we care about this? Let's get rid of that. Right, so it's reporting keys, right? And you like moving the analog stick, it's doing stuff. Right, it's just reading all the keys off, which is nice. This is what we want. But I can't seem to do it for the accelerometer. Accelerometer needs sudo. Okay. Oh, these Rust people. Write it in Rust. Do 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 do. That's fine. That's fine. People can be better. That's fine. evdev accelerometer. So we're looking at kind of doing like sensors. Need pseudo. See, I don't want to change any group or anything. Um. Uh, mm, Unless they're using the old joystick API for it, which would be weird. I don't know how STL does it, but they might be using the old joystick API specifically for these accelerometers, because they do have the code in there. Right. Let's re-enable this one and see if we can see anything that stands out. Accelerometer. So it's on JS1. We can access this. This one we can access. This one we can't. Event 20. Permission denied. Like the user shouldn't have to configure their system to get this to work. So accelerometer. Yeah, these ones are expected, right? Keyboard and mice. But there is X input, right? Sorry, what is it? Lib input. It failed to open event 20. It just failed. They failed to do it. Just in mouse motion, so obviously they don't support gamepads. So I don't know, should we do a custom build of SDL2? And then we'll figure out, like, we'll debug it and just see how are they doing the accelerometer, because it just doesn't seem like the only way I see possible is they're using the JS, the joystick, old joystick API, because it just seems weird. Yeah, so if they're in the Linux side of things, there is that JS, right? handle classic events. I reckon they're using this. But I don't know. And they use the classic events of classic. Right. Yeah, so maybe we'll see if we can put some prints into this and compile it. But yeah. All right. So yeah, I think I've got to bust a move because it is getting late and I do have work tomorrow. But yeah, I'll next be on Tuesday. So I think on Tuesday, what we're going to do is we'll dig into the SDL. We'll compile SDL custom. We'll put some prints around and have a bit of a play with this controller, see if we can get the accelerometer to work. Like, we know how to get the button presses to work and everything, but just the accelerometer and the gyro, it seems there's a bit of a problem. So we'll figure out that, and then we'll write up all the code and get it all hooked in, which would be super nice. But yeah, that'll be next stream. So our next stream on Tuesday, 6:30 p.m. GMT +1, and also on Thursday. Yeah. Oh, that's very frog bottom. Yeah, there's some good stuff. Okay, thanks for coming, everyone. I'll see you all in a future one. But yeah, we've got multiple keyboard and mice happening, so that was really cool. All right, have a good one. See you later. Bye-bye.